Alton, mute your mic.
Why you rough him up, sir? Alton, you tonight. Good morning, guys. How you doing? Hello.
Good morning, Mr. Shan.
Yeah, good morning. How you doing, Papa? Everton, me here to sleep in your voices today.
Sir.
You sound like in a bed same way, you know.
No, sir. I still get up on my desk, sir. My day I have to do some work, sir. But yesterday, we have election on CXC yesterday, sir. Election on CXC at St. Lucia yesterday, sir. Run all up and down over them networks, sir. Mash up, sir. Tired. Want sleep.
You know, I'm just really proud of you, but You know, put it this way. Put it this way. By the sweat of the man's brow, he shall eat food. Sometimes, Everton, I am right where you are. It's like for last week. No, last week was a little easier for me. Even though I finished my indoors this week. You see, the week before I started teaching this school, I was under pressure. I mean, to be honest with you, I don't know how it is. Well, I know how it is that I came through, but you couldn't tell me that I would have been able to breathe somewhat um, for this week. And mark you, I still have a batch of papers to mark, a mid-semester paper to mark for last semester. But considering that I had 5 courses teaching plus administrative work, I really, in my view, think that I'm doing pretty well. The grades are up nonetheless, but it's just that I need to just go through this one little piece for the students. And my aim is to do it today, so, well, preferably today after class, or worst case scenario tomorrow, so that Monday morning, first thing, the grades can be released to the students. What I'm happy about though is that my deliverables for this semester, mid-semester for you, your exam paper already done. For all the courses I'm teaching this summer, I've already done the mid-semesters and the final exam and send them off to the respective, units. So I'm a little freer because trust me, I know I won't be traveling for this summer because this morning I'm up from about 6 o'clock and I, do my little prayers and my little reflection and I took up the phone and started reading some news. The Delta variant is highest in Florida than any other place.
Mhm.
Bro, let me tell you why me worried. Me boy, why me worried. Florida is Kingston 21.
Mm.
And
Eh,
so many of our people going from Kingston 19 and 8 and this and that to Kingston 21 to come back here. So inevitably, the Delta variant, if not already here,
You know it there, man.
same
Doctor
thing.
tell me, Dr. Brethren always call me and tell me. Say it is here. So I need to turn on my yard. Him call me and tell me whenever nothing wrong, him take up himself and go up
Mhm,
on our house where him grandmother dead left him. Where when
mhm,
Corona, when COVID just started get bad, little
mhm,
before it get bad, him see the first couple of cases and the first couple of people were dead at Spanish Town Hospital.
mhm.
Him him
Migrate.
refer him send man up there. Go put on room, bathroom, and living room. And him literally build a house around the little board house. And then put on the lick down the board house and put on the roof and set it up. So him have him son where have what I'm calling Down syndrome.
Down syndrome. Yeah, man. He's
Him
vulnerable.
him carry him son and him girlfriend go up there and them stay up there for 8.5 months, Him not go work, Just tell them say yo. Yeah.
Hmm.
And him go up there. One doctor time of him private practice and 8.5 months him go up there go sit down for. Right?
It rough, and I suspect, though I'm not sure, but I suspect that one or two students of this class may very well are traveling, intend to travel,
Mm-hmm. Hi.
or already, you know, is in the States. I think
Oh.
of, Mark, it's online teaching for me, so I mean, we can't catch corona through the phones or
Sir,
through
I'm gonna be,
the.
sir, I'm believe me. I'm afraid I am, sir. I'm yeah, like cough that day, sir.
No man, me good man, no man, me. Oh
No,
goodness gracious,
sir, you go give it the cyber variant of this thing, sir.
Adrian, let me tell you something. Yesterday, me drive over to Ochi, and you see when we enter the toll,
Well, you gotta live life, man. Where
no
you
man,
go?
no, you have to, you
Pear
have
tree,
to.
you go? You go
Yeah,
where
no
you go?
man, no man, that's why I don't drink go wash up because are the stress off for me. But guess
Yeah.
what?
I hope
The
that the
truth,
people them from Miami are go wash off the stress, so that mean infected already,
no
sir.
man, no, clearly not. The salt water body off. Put it this way: when I enter the toll and I get the card,
Come on.
I slow down Didn't come to a complete stop, but I slowed down, took up my bottle of alcohol,
And spray
and
the
I
car
went.
and the people lift up.
They may
It
wash.
happened
No,
to me
ma'am.
too.
No, but Bridget, you see that car? It goes under the mat. It don't go anywhere. It's in the car because we don't want to contaminate it. It goes under the mat, the floor of the car, under the mat. So when I reach, I take it from the floor of the mat. Yeah, some people put it in them this the floor of the mat, and I wash my hands with alcohol. Having done that, matter of fact, and when I'm driving up, I put on my mask. Let alone somebody before me will cough or sneeze, and the particles are still running up and down. Uh, but what's the point I'm making? Um, Coronavirus have to come good to catch me
Oh,
because I if somebody have got cat and come give me because me not tell you, me not come in contact with me. I believe I would have come in contact with somebody with COVID or COVID come in contact with me already, right? But the way me protect myself to the detriment of my health. All when me yesterday when me have climb up on them 1 million on one staircase from the bottom of the falls up to the top because they're doing some refurbishing. So some of the rocks are very slippery, so that them tell people say them can't climb all the way up because they need to clean the rocks, right? And I decided that me not climb the falls again. I will take the treacherous road and walk up. So when I finish, I could not breathe in the mask. It took me to take it off, let alone
yeah.
somebody pass me and go, no, it not catch me off guard.
Yeah. A lot of people don't understand that someone can walk past you with
Mm-hmm,
COVID and you get COVID.
mm-hmm.
You don't have to stand and breathe in your
You
face.
don't have to. So when I talk about the 6 feet social distancing, you
It no
don't.
makes no sense
M-
because
m- m-
the droplets are still in
absolutely,
the air once the person
absolutely,
passes. Whereas if the
absolutely,
person is speaking, coughing, sneezing, anything
absolutely.
at all,
Some people
or
talk and them rain and rain fall from them.
hold on, and that is not even it. If someone is walking briskly and breathing heavily,
Yeah, man,
it's just as bad.
you have water ear droplets.
Mhm.
Yesterday I was me mark up my space and I beat my body with the balls. And one little youth come and brush against me.
Well,
I vex, I vex, I vex, I vex, I vex, I vex. I'm going to come out of the water to show you how paranoid I am. Come out of the water. I'm going to go for my buckle of sanitizer. I'm a, I'm a sanitize, right? Not only the one arm that him touching on, but the two arms both arms, me sanitize and them laugh at me and say, you in the water. Me say, I don't care.
Yeah.
Because if I don't do it, the whole journey, me will think say sitting wrong with me. You
Mm,
understand? But
yeah.
guys, I just say this to say to you as I, you know, give you a little pep talk before that I really want COVID came close to me in in that I have lost quite a few of my church family, mainly senior members of the church because of COVID.
Yep. 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 Yep.
I have not seen them. Well, I would not have seen them for over a year because COVID came in 2020. I wouldn't have seen them for over a year. But I remember
Oh,
one
COVID.
lady, no, she was here from 2019, but I mean,
Yeah.
the lockdown came 2020, March. But this lady, senior member of the church, her son brought COVID into the house. She caught it. Both of them had it. The mother first died. Both of them were in hospital. The mother died, and hours after the mother died, the son died. Right? So it has, and not for, I mean, I've had one, two, yeah, three students that are close to me who would have had COVID. Um, and, two of the students, funny enough, from one program, um, I was still teaching them while they have it. And I mean, I said, don't talk, just listen. So it came pretty close to me. So I say this to say to you, without identifying anybody, but I say to say to you, um, just be careful, please. Sometimes I'm driving on the roads and I'm saying to myself, COVID now keep a Jamaica. because people are walk up and down without the mask. And all when COVID done, all when the international news said, "Oh, we are free from COVID. COVID is non-existent." This boy are still wearing his mask. So I say to you guys, please be very careful. Those around you. I am not one who's going to be saying to you that you must get the vaccine. It is a personal decision. If you feel led to take the vaccine, go ahead and take it. If you don't feel like you want to take the vaccine, no, go take it. I'm not going to say to you, don't take it or take it. It's a personal decision. But whether or not to take the vaccine, please to continue wearing your mask. The vaccine only minimizes, quote unquote, the effects of
Uh,
the virus.
yeah,
It doesn't
but
prevent you from getting it.
a lot of things that the people don't understand is that it 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 the vaccine makes you asymptomatic. You still have it.
And you're correct. So you will not become a carrier. So
Exactly.
if you are
So
around somebody who is unvaccinated, you can actually infect that person.
and that is why they are saying that they have different variants of it now, because people are
Absolutely,
not getting sick.
absolutely.
Then the actual human body is mutating the virus, and then once it is mutated, then it starts up. There's all of these places that they're saying the vaccine was widely taken. England and all of these places, these are where the variants are coming from.
Look at where that's exactly so. That's where the variants coming out of because of this mutation, and this is a mutation, just like HIV/AIDS. One person with HIV go and get entangled with somebody with another HIV. That person has a different strain from the strain of the other person, and both of them coming together now creates a new strain, and that
Mhm.
new strain is um is sometimes, it takes much more, that new variant, it takes much more to combat it. And
Mhm.
but the truth of the matter is, in the news now where people are dead from HIV when HIV just came out.
Oh,
I mean, I'm not saying that people are not dying from HIV, but
yeah,
I'm
but
just saying that it is, people say give me HIV as opposed to corona, because people not dying from HIV. Matter of fact, the technology now is that
yeah, and
Magic Johnson.
retrovirals and all of these
Yeah,
things.
you can outlive HIV and still enjoy life, if you know what I mean. Enjoying quote unquote quotation because you still
Yeah,
can protect
yeah,
yourself and
yeah,
enjoy
yeah,
life, right?
yeah.
But I just say this to you guys, please. My thought this morning with you is to just protect yourselves. It is, I can't overemphasize, the hear upon the news yesterday say, well, not yesterday, yes, it was Thursday, Friday. Thursday, Hotline had some promotion, tourism sitting at the Pegasus. And Edmund Bartlett, the Minister of Tourism, came on and was saying that, if he had his way, he would make the vaccine a must. And I said, interesting. And then he said that if it is that you want to work in the tourism sector, you must take the vaccine. And I'm saying to me, I started thinking, I was driving and I started thinking, as I often do, what about those teachers who have decided not to take the vaccine? Is it that they'll be out of a job? How would they take care of their families? The vaccine is said to be used for emergency uses only, and if person, I have to respect Orlando's point of view. If Orlando said to me, sir, I will not take the vaccine, I cannot say to Orlando, take the vaccine because you know what happens? And this is why I've taken this position. Me will tell Orlando to take the vaccine. Orlando don't even know that he has an underlying issue and take the vaccine and sitting around with Orlando. I will live with that guilt for the rest of my life. One of my mother's friends, um, her and her mother took the first dose of the vaccine. The mother went and apparently took the second dose of the vaccine and did not survive. I don't know if it is the onslaught of the vaccine that killed the mother, but this is what the daughter believes. And because she took the first dose, the Ministry of Health contacted her for her to come and take the second dose. And she cussed them out good and proper and said, no, call back my phone. And I'm sure she used some very colorful words too, right? because she says the vaccine killed her mother. Now, there is nothing that she can say to get from the government for her mother because the pharmaceutical companies have put it out there that it is for emergency uses only, and there is no liability that can come against these pharmaceutical companies. And namely the four, the Moderna, the Johnson and Johnson, the Pfizer, and the AstraZeneca, with the stuff. So me, I am not one. If you're going to take the vaccine, I'm not going to say don't take it. I will never ever say to somebody don't take it. And I'm saying to you, if it is that you don't want to take the vaccine, I'm not going to say to you, don't take it. All I will say to you is make sure you cover up, mask up, you sanitize yourself. My hands are now look like hands of maybe a 50-year-old person because of the amount of time I sanitize. And I don't care because after COVID, there are products on the market that I can use to get back the nice smooth hands that I have because these sanitizers dry out. And because me paranoid, me I use it 3, 4, 5 times in one go. So I'm just saying to my students, please I beg of you, you go to work, don't say, oh, we in our office and everybody cold, negative, because you don't know how Shand associates outside of the office. Me, I'll be the one who have got to party them with the tapanaris them, and at them are carrying something, and me come and work and behave as if, oh, I am this nice person and I don't go out. And bam, assuming give you COVID. So already in your office space, wear your mask. Don't relax it. Right? People say, oh, I want to take off my mask when I'm going to the cafeteria. Me not even eat in the cafeteria. Straight up. Me when I'm a car, or me go somewhere and take a little one bite. Me not eating it because you don't know. So what's the moral of what I'm saying to you? Take the necessary precautions, please. It's tough. It's tough. I have spoken to students who have had it. I've spoken to to other people. I hear other people's story. It's tough. Me don't want it happen to Uno. Be careful. All right. So trust that you had a good night's sleep and that you're ready for this morning. I reflected on the class I had last week, and I thoroughly enjoyed it. Funny enough, it's a Saturday morning, and I won't say that you guys have disturbed my Saturday mornings. No, because it is a very good feeling. I love what I do, and especially when it is that you guys are following. To be good. I get very miserable though when I give you work and I don't do it. So let me ask a question. Thanks again, Peter Gay, for holding me accountable. Honestly, I thought I had circulated the notes last class. When Peter Gay called me and said, sir, send me something. I'm saying, okay, she asked me to do 2 things and I did one. And she said, but sir, you're not. I said, no, man. She said, sir, nothing at the WhatsApp group, checked. And when I did look in the WhatsApp group, I recognized that it wasn't. Similarly, I'm teaching business calculus and I went to class and I was there saying, okay, students, remember last class? We looked at the chain rule, and we looked at the product rule, and we looked at the quotient rule. Let us go. And the students in that class and said, sir, are you sharing a screen? I said, no, we did this. They said, sir, are you sure? And I said, Rowty, forgive me, guys. I had a class on Saturday and this is what I did with the students. So you have to forgive me. I'm teaching 2 calculus courses this semester. And some of the things that you will do, they will do it. So like Newton-Raphson, they don't do it. But like the rules for differentiation, they will do it. So me go on and mix up the class with them. So I had to ask them to forgive me. Tell me what it was the last thing we did. And then I got back on track. So you have to just hold me accountable. Don't think that I don't want to do it, but just hold me accountable. Because sometimes, with this pandemic and online, and I can't walk when I look in my book to refresh my memory, things will happen. So thanks again, Peter. But having circulated it, how many of you were you able to get a chance to go through the other? I think I gave you two additional questions.
Sir, morning, I'm not in that group, sir. Can somebody put me in that group?
Oh, geez, can I please add my chance to the group, somebody? Peter Gay, please.
So I just send her number in the group. So I could
send a number in the chat, Chance.
Peter Gay, is Everton in that group, Peter Gay? I'm just checking.
No, in Everton. I'm at it right now.
You see these things are what I talk about.
So sorry.
There's just you know.
Never mind. Spread the love.
Everton, I am so
It's a
sorry. I'm
love.
gonna add you
It's a
right
love.
now.
It's a love. 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 All right. Now, remember now, I am going to just review, we call it Newton Ramson. Review, you notice I said review, not to reteach, to review Newton Ramson. And then I'm moving on to something else. Now, I think Everton was the one who asked the question last class. Sir, can we run through the exam paper? Sorry, somebody said, sir, who was that?
All I understand. Did you create a new group, sir? Because somebody says I don't think myself or Kim or anyone from
All right, do me a favor. Do me a favor, Lando. You and Kim, just put your numbers in the chat. Peter Gates, my able administrator. Just put your numbers in the chat, please. And she will add you. Thanks again, Peter. So Everton asked last class if I could go through the exam paper, and I was a little reluctant in doing it because I know what it did to me when I was studying. I was always very enthusiastic, and the first class we said, sure, it's easy, and get the past papers and then get very depressed. All right, because of course I don't learn some other stuff. I don't want that to happen to you. So what I'm going to do is I'm going to go through the 2 questions as a review, and then the question that we got on the exam last year on Newton Ramson, I'm gonna give it to you. Do I have it, Jesus? Oh Lord Jesus. I'm gonna check. Oh Lord, I wish I have it as soft copy. I'm gonna give it to you. So it is that we can work on that. Now, when we do the past paper on that, last year's past paper, or last semester's past paper, that is going to be the end of Newton Raphson, and then I'm going to be moving into another aspect. You know, one of the things I want to move into, I want us to play around again with some more differentiation. We are on differentiation. I'm being very strategic in this course because we have a few weeks. I am sure, I know when I taught the other group, I think Peter Gay, when I taught Calculus 1, I think Peter Gay was there, Alton was there, Everton was there, Shanice was there. Yeah, I had those 4 students. They were very creative. Some mornings, you know, Saturday mornings would have had a class, and if my internet access is unstable, they might say, sir, just we could come back 6 o'clock, the same day, and just drive for 2 hours and we'll go there. So they were very good in that regard. So I'm trusting and hoping that based on my evaluation of the times that are left, that when I do call upon you to make a put in a little extra piece, that you guys will, you know, be available to just go through some stuff. I am not worried whether or not we're going to pass this course. I am just worried that I want us to just go through the thing because you will pass the course. Give me your 100% and you will pass. Give me your 100% and you will pass. All right. Now, let me just, let me share the screen. Let me share my screen. I cannot overemphasize my students. I cannot overemphasize the importance of keeping up with what is happening and doing what it is that I ask you to do. If you have a difficulty, do it, have a difficulty, and let me know that you have a difficulty. Don't just sit down and not do what it is that you're supposed to be doing. Ouch! Oh, Lord. Now, I did ask a question. I don't get a response yet. Were you able to go through the question on the questions on Newton Ramson that I sent in the group?
Sir, if it was not Saturday evening, I didn't get it, you know, but if I can't get it by Saturday evening or Sunday, school work sticky for the whole week.
Got you. No. Everton, don't say another word.
Key.
Don't say another word. I have a research that I did on my system now, and the only time that I can get to edit the research is on the weekend. You see, once Monday come in, it did because I have class and it just get dead. So I understand that. So don't worry about it. So now that you tell me, I will ensure that I send all the stuff. You know, if not immediately following class, the same Saturday. But sure, don't say another word. I'll get you. I'm right where you are. All right, nonetheless, let me just use the time and then go through the stuff. So remember what we did for the Newton Raphson. We looked at where is Romario? All right. All right.
Sir, and about
Yes,
20
Papa.
people in a class are 30. How much people in that class? I mean, I mix
In
it
this
up.
class,
Yeah.
not as many as 20. On Edico, I'm seeing 10 on Edico.
Oh.
I'm seeing 10 on Edico.
You know that
Sir, when I
uh,
get that educator because when I go for register for the class registration close.
Don't worry about it. Because the course started late, you won't be charged Alton any
sir,
late registration. So I'll get you on Edico. So just remind
when
me.
I
Go ahead.
think Macintosh was saying that he got to Chevron late and it was closed. We can still call him, ask him
Yes,
if he want to do it.
man. Listen to me. Absolutely. Absolutely. No, man. Get them, man. Get them. Let me tell you something, guys. Let me tell you this. Just one quick thing. One quick thing. And this is a secret between us. Many of you may know, and others of you, it may come as a surprise. I'm the head of the math department. All right. And one of the things that I say to my team, and one of the things that when I go to meetings, I say to the other heads of school.
Kelly, sorry, excuse me, sir. Kelly, add Macintosh to the group.
I'm going to call him and find out. I'm going to call him and find out now if he want to come in the class. Because this is the second class.
Audio as well.
All right.
Right.
All right.
So one of the things that I keep saying to my colleagues is that I don't want it to be said, like I have 2 students in this class that I remember when the papers were marked. I personally wrote to Mrs. Campbell and say, I have 2 students in this class that I know for a fact that they are completing their degree the end of August. Please, it doesn't have to be me, but please have a fast track for the Calculus 2 to give them an opportunity to finish up. I know one student just have one course, Calculus 2, to finish off. You understand? I don't want anybody to not complete their degree and say, oh my goodness, what course you have? Maths. No, I don't want that to be said about any of my students. This is why the truth of the matter is, you think I really want to come to complete for a Saturday morning? Absolutely not. But my wife said to me yesterday, so this class now is every Saturday? I said, yes. She said, so why you have to teach a class? I said, well, there's a class and nobody else is available to teach a class. I'm the head of the department. I have to do it. She said, okay. But the truth of the matter is, and this is why I take the approach I take when I teach, because I want to give my students the best available option ever. So I'm saying to you students, please, I want when I submit my grade sheet this semester that I have passing grades. For me, right about now, I'd rather see a C minus than a D plus. You understand? Not that we're working for C minuses, but I'm saying to you students, please, in Jesus' name, do what I said to do. You have to do your individual work, so it is that you can learn from the process. It don't make sense you get help to do the pieces, and then you still don't know what to do because when you go into the final
Sir,
exam.
him say him in 100%, and what did you? I told him your email address, and so him say I'm going to contact you.
All right, cool, no problem. So I'm just saying this to say to you students, if you know anybody else out there who has a calculus 2 and this is what is holding them back, send them to do the class. Send them to do the class, right? So that's just what it is at my little 2 cents as it relates to that. Let's go. Welcome, O'Shane. I see you just joined. All right. So what it is that we did last time, we looked at the curve f of x. We looked at the curve f of x. So this is my curve f of x. Now, in looking at my curve f of x, I am doing a differentiation. It's a differentiation that I'm doing, you know. I'm doing a differentiation of it, but it is an approximation that I'm looking at. So if you look, you see that solving polynomial by using approximate or numerical method, and this is a Newton-Raphson method. All right. So So I'm actually doing a differentiation and I'm solving the differentiation at different points. Now look at what is happening. So I have my curve here, and with my curve, what it is that I'm doing with my curve is I'm looking at different points. I'm calling this X1 right here. This is my initial guess. And it did say guess because someone may say, sir, why you start right here? So I could have started X1 right here, so too. But this is just my initial guess to get as many points in on this curve as possible. The more points I get in is the more accurate it is, right? So I'm starting here with my X1. That's my initial guess. I'm going to draw that vertical line up to the curve that is parallel to my f of x axis. And then when I do that, what is going to happen now? That point, I'm going to draw a tangent to the curve at that point. The tangent is going to be the base of my second approximation. All right? Now that second approximation, I'm going to draw that vertical line again, parallel to the y-axis or the f of x axis. This is going to be my second iteration. You notice this says after first iteration, this is really my second iteration. And this initial guess is really my first iteration. All right? So my second iteration, I get that value here. Again, I'm going to draw a tangent to the curve where it touches the x-axis here, because my aim is to get this exact root. Where it touches the x-axis here, I'm going to draw a vertical line parallel to my f of x axis, and again, I'm going to draw a tangent to it. So each time, as you see, because my axis is, my tangent is being drawn, I'm getting closer and closer and closer and closer to this exact root. Now, what needs to happen is for me to get that initial guess as close as possible. I need to get that initial guess as close as possible. Now, how am I going to get this initial guess as close as possible? Now, we spoke about getting your intervals, and I will say to you, hold on a minute, please. All right, so I'm getting as close. Let me stop share and get rid of this thing. I'm getting as close as possible to my initial guess. So what I do is add my lower limit to my upper limit, and then find a halfway point between. So if my boundary is between 0 and 1, if my boundary is between 0 and 1, what I'm going to do is add 0 to 1, and I'm going to get 1. I divide it by 2, I'm going to get 0.5. So I'm going to use my initial guess as 0.5. If it is too far from it, after my first iteration, it's going to come out to be closer to what it's supposed to be. All right, so that's what it is that we do. So what we did here was to look at an example, and I won't go through that example again. I think we went through this example here in class. Yes, it's 0.81. And what I want to point out before I do the other two questions, what I want to point out is it says, given the equation, bam, that's my equation, show that the equation has a root in the interval 0, 1. Hence, find the root to 2 decimal places. No, that piece is important to 2 decimal places, right? To 2 decimal places. Because when we did our stuff, the first iteration, of course, this is 0 and 1. 0 plus 1 is 1 divided by 2 is 0.5. So that's why I'm using my first iteration, x1. Use x1 to be 0.5. All right? So I'm using my x1 to be 0.5. Sir, why? Because I'm finding a halfway point between my interval. So I'm going to get the 0.5 right here. So having used 0.5, my...
Sir,
yes,
would you mind making a note that once the first interval, how to find the first interval, that you would then add the 2, then divide it, the 2 numbers, and divide it by 2?
If you want me to make a note, I can, but I mean, if I said it last time, do you know?
No, you are going to say that, but when you send me this document and I'm going through it the night after exam, and I book and say, how him get that? Why him use that? Why him do that? I don't want to have to commit that to memory. I
All
want
right,
to have
okay.
all my steps down, right? I don't want to have to remember anything. Math is a linear thing, right? You do
This
it.
is so the first attribution is um let's say how can I make a notation that if that's what x is equal to that, the first attribution is seems exactly true. That is that is um
Sir, you recommend we do the masters, I said, sir. But ask everybody that question then, sir.
yeah, absolutely. We're developing a brand and and I know I'm being recorded and this can carry me to my grave, but let me just tell you how I feel about the matter. Why I do recommend you doing the masters at said is, you know, the teachers, right? Not that the teachers are going to see plus one. Not that the teachers are going to come and say, okay, Everton, you failed, so I'm going to give you a passing grade. Well, none of you can say that because
True.
all of you would have done Calculus 2 before and didn't get through, so you're doing it over now with Mr. Shan as a fast track.
And Calculus 1.
And Calculus 1. But guess what happened? Guess what happened? The point I'm making is Everton. You know a teacher like Mr. Shan, and you can say, boy, sir, you know, say, a group of my friends, you know, we never pass programming. How about starting up a programming fast track? So you're available? And I may say, boy, Everton, sister, just see if you can just do something, man, and just have a fast track. And we will go through and just create a fast track and give you guys an opportunity to pass. The point is, some of the other institutions, and I can speak particularly about UWI, since that's the only institution that I know. I've gone there 3 different occasions, and I can tell you, they don't facilitate that sort of process.
You have to wait until the
You have to
next
wait
year.
until it's offer. And I can speak definitively about UTEC. And I said, this is a private situation I'm going to talk about. One, my sister was at EXED, and I said to her, stay at EXED. If you stay at EXED, you don't have to worry about school fee because I will pay your school fee by salary reduction, right? You can go to school free of cost. And my own girl said, no, she want the name brand, she want the UTEC brand. I said, okay, go ahead with the UTEC brand, to the point where me, she, and my mother fall out. Because I'm saying to her, okay, go to students loan, do your stuff, rate, support, and so on, la 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 di. Home girl never did accounts in high school, but home girl wanted to do a business degree. And I said to home girl, just work with me, man. Just spend the 4 years at EXED. And she could tell her mother, of course it's my mother too. I'm sit down and listen to the two again. I'm gonna get vexed. I said, do me a favor, it's your life, do what you must. Because me know as the educator in the family, everybody a banker, you know, me know as the educator in the family, say, me going to have the last laugh at some point in time. Girl successfully completed year 1, failed 1 course, accounts. And I said, oh dear, but I did say to you that you needed to do accounts. Oh yeah. Don't remind me. It's okay, no problem. Girl went to second year, did over the first year. Remember, no, she couldn't do summer school because you don't facilitate them something like how we are facilitating this course. Girl failed. Girl have to go second year, carrying the first year course and do the course, pass it, right? And so forth and so. So every year she failed only 1 course. Every semester, rather, I should say. Not a year, but every semester. So in the second semester, she carried forward that course and then pass it. And then, so she was 1 course behind in accounts. And in her final year, somehow she caught up and ended up doing 2 accounting courses at the time when there was no prerequisite for one of them.
Yeah.
Or, you know, so she passed, so she ended up doing 2, so she catch up. And girl came to me, very happy one day. I said, Jesus, brother, we finished the degree. Can you believe somebody do 1 accounts course, one day at a time and pass it? And I said to her, congratulations. And we started celebrating Rockstone about 2 weeks after she come back on them system and check. And Homegirl failed. Then changed it, revised the grade, and Homegirl failed the course. And Homegirl touched me and said, can I do the course in the summer so that I can make graduation? You know, you
No.
text Homegirl.
Next year.
Next year, second semester.
Rotted.
Not even in the first semester. No. So Homegirl sat home 1 full year waiting to do one course to graduate. No, me I got tell you something. I mean, I'm not being recorded, and I know this can carry me to court. That will never happen at Exed. And in as much as how some of them cuss out Exed and say Exed wicked and this and that and all them want the money and support, I can guarantee you that will never happen at Exed, because me sure say that one girl go talk to her teacher and say XYZ, even if it's one student, that teacher will say okay, and how she failed the course, it would have been, it's a close fail, a very close fail. She could have done a resit, not even a read, you know, a resit of the paper. She had to wait 1 year. Okay, worst case scenario, offer the course in the next semester. No, 1 full year. She couldn't get a work. 1 year, missing one, the office support. And I told her, I said, if only you had listened to me. And she said, you know, brother, now it is that at the end of my studies, I am understanding what it is that you're saying. So I say this to say to you, Everton. Not because I work there. My sisters came to Exeter. And not that they couldn't go anywhere else. You understand? But because I'm working there, I said, no, come. And I'm going to say to you, all of you, if you can come there to do the masters, come there. You know the lecturers. The lecturers know Uno. The lecturers will facilitate you. These other places, name brand places, they are not there for Uno. Me can't speak about that because I went to that place at Mona, right? And my 3 times going there, I was not a happy camper. All right. So I just say to you, yes, go ahead and read. All right, see your Everton. So what I put here is that is 0 plus 1 over 2 is equals to a half. It is 0.5. And that's what I got the 0.5 right here.
Okay, first
right?
iteration. You did
Sir, put
half
the
it.
0.5 in the bracket and the 0.5 up here in the same color, sir.
Sorry, with 0.5 only. This 0.5 right here.
No, sorry, the 0 and the 1.
Mhm.
Here plus the 1.
Put it in with 0 plus 1.
Different color. Yes, sir.
So you know that is that 0.
Say,
so you know,
say yes.
all right, no problem, Chance. Anything for you, guess what? I want you to catch it, so I can do that. So
Or if we stick together to slow people in that class.
no, only not slow. Only not slow. Stop it. I'm buying that thought. Only not slow. All right, Chance. Look at this, Chance. This 0.1 in blue up top here. Does that help? That 0.1 in blue here to the 0.1 here. Does that help?
Yes, sir.
All right. Let me do something else. As you asked for that, let me do something else. Let me do something else. All right. I put it in brackets so that you can see that it's the same 0 and 1. I just adding them and dividing them by 2. Does that make any significant difference?
Yes, sir. Thank you.
Yeah, man.
All right. Hold on half a second, please. Half a second.
I forgot to call Miss Campbell about or email her to send the information to me about the master's program and the costing and everything. Let's see if we can reach her. Usually if you call, if you email her within 10 minutes or 15 minutes, you will email her back, you know. Need some info on that.
All right. So now you know. Oh crap. So
Sir,
knowing, yes, Papa.
I have a question. The
Go ahead.
master's program, sir. We're gonna get calculus tonight again, sir.
I doubt it. I doubt it. I doubt it.
Which are the math course we're gonna get tonight?
I have not seen the curriculum, but I doubt it. I doubt it.
It's in MIS, right?
You know, if as many of you as possible indicate that you want to do MIS, they will start a MIS program because we have the lecturers there who can teach a program. So yeah, it can be.
Sir, so how many PhDs we have at Excel like that? Is that what
I have no clue.
Sir, because, true, me know, say, let me tell them, say, me I go page one doctor. Them say, which hospital him work? I say, cool, man.
Cool, let's go. All right, so this is 0.5. So that's my
Mhm.
first iteration, and it's the same
Mhm.
thing. So Shanti can see now that this 0 plus 1 is from the 0, 1 right here. That's
Mhm.
my first iteration. Then when I look at my second iteration now, I am putting in the 0.5 into the function. And when I put it into the function here, whatever comes out is going to be my x2, which is 0.8181. Where's Romario? You're not coming to class today? No, today. All
All
right,
right,
so then,
so, all right, hold on. So you
mhm.
put it in there, you differentiate,
Come on,
you
is
put
one time
that, right?
differentiating. Sorry, hold on. Remember, is one time you're differentiating. Somebody asked that question last class, and I did say it. Is one time a different? Oh, let me put a different color. Is one time differentiating, one dege time, and the differential is going to carry through with all of what it is that you're doing. You're differentiating only once.
Sir,
Yes, please.
by the time we finish with this document, you're just going to give this document to people and then tell them come do the exam.
No, true. And that's
You
why
see.
I keep updating as I go along, because based on the questions, it's like what Shani said, sir, put it this one and this one here, so the colors here and here, so I can see it. Yeah. So that's why I keep updating. So this is this differential here.
Yeah.
This is the same differential I've been copied because I think I recalled it somewhere else. No, I didn't actually.
No,
But
hold on, sir. Stop. So you're saying right there where we put in the 0.5, which is x, the second iteration there, right? This line here where I'm seeing x 0.5, which is equal to 0.5 raised to the power of 3. The next line is differentiated.
And that's the differential that we just looked.
Okay, and that's it. That's what I was saying. You differentiate that once.
No, man.
The first time.
Hold on. Because you see this line here, that line there is from the differential. Remember this recall here? Remember we differentiated the function once. And we got f dash of x to be equal to 3x squared plus 2. It is that 3x squared plus 2 that we substitute the iteration in.
Oh, because I was going.
Watch here, RECALL. It is the same differential. See here, 3x squared. All I'm doing is substituting the value of x into my differential. See here, the same plus 2. And if you look at it here again, recall, RECALL, bam, is the same iteration, is the same differential that I'm substituting in. I think Peter Gay asked a question last time, but it's the same differential. All I'm doing is each time substituting. You see, this is my x3. So my x3 here, my x3 iteration is 0.7732. See here, 0.7723. I'm substituting 0.7723 into the differential, the same differential. It not change. It not changing. See it here, recall. It's the same differential that I'm substituting the new iteration. This new iteration is 0.7709. See here?
Okay.
0.7709 is the same. So you differentiate the function one time. Absolutely. And when you differentiate the function one time, you are going to be substituting the iterated value. Because when I move on from this, guys,
sir,
hold on.
Go for your buckle of water and keep it. You seem like
me drink my tea already, man. Me drink my tea already. Me drink my coffee already, man. So I'm alert. All right. Watch me. SUMMARY. There's no E. All right. Summary. All right. So watch what I'm going to do. 1. DETER. Determine the value of the first iteration by finding the midpoint, MID. You understand when I say finding the midpoint, chance of the interval?
Divided by 2, the same thing.
Yeah, that's it. Chance, you understand when I say it like that? Finding the midpoint is just a halfway point between.
Yes, sir. Yes.
All right. So the sum. So what I'm doing, I'm giving you a step-by-step summary now of how to go about doing this question. All right. So first, you're going to determine the value of the first iteration. The first iteration. All right. By finding the midpoint, MID, finding the midpoint of the interval, of the given interval, of the GIVEN, of the given interval. All right. The next thing is that you're gonna differentiate the given function. Right? So when you differentiate the given function, you can have that. Then you're going to use the formula, formula. Let me just go down and copy the formula. You can use this formula, copy, paste. You're going to use the formula that to substitute substitute to substitute the first iteration. To substitute the first iteration in order, ORDE, or in order to obtain OBTAIN, the second case, the second iteration, SECOND, the second iteration. This process, PROCESS, is repeated as many times as necessary, NECESSARY, until the desired DESIRED RESULT is achieved. Done, PROCESS, right? So that's what it is that I'm saying to you. And that's all that there is to it. No, me never did this summary for nobody before, you know, but I'm doing it for you guys. What the summary is, first, you're going to determine the value of the first iteration. You're determining the value of the first iteration. You're determining the value of the first iteration by finding the midpoint of the given interval, right? When you find the first iteration, then you're going to use that. You're going to differentiate the function, because you have to differentiate the function. So differentiate the given function. Having differentiated the given function, you're going to use a formula, x to the n, bam, 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 to substitute the first iteration in order to obtain the second iteration, right? So you're going to put in your f of the first iteration, and then the f dash of that, and then you're going to do all. So in this third line, you're going to have note. You will be required to make SEVERALSUBSTITUTIONS, right? You'll be required to make several substitutions. You will be required to make several substitutions, right? And I just want you to note that, because I want you to note this, because you're going to be required to make several substitutions, right? And the substitutions here will be, for example, f of the first iterated value, f dash of the first iterated value. That is f of the first FIRSTITERATED value and f dash. Oopsie daisy.
Wake up, sir. Wake up.
Man, it's just that I need to copy something. Copy, paste, f dash. Of the first iterated value. And so forth and so on, right? So let me just.
Sorry, sir. Peter Gay. Put
Yes.
the link. If you can put the link in the chat, so something they can join. Where name Macintosh can join.
I added him already. I added him to the group already.
No, I'm saying drop the link for the class in the chat. Because I'm not gonna get the email. I'm not gonna get the email because he's not.
I'm gonna do that.
All right.
All right, I'll do that.
All right, so let us see, reread this and see if this makes any sense. I'm going to use a formula, that given formula there, to substitute the first iteration, in order to obtain the second iteration. All right. Note, you'll be required to make several substitutions. That is, f of the first iterated value and f dash of the first iterated value, and so forth and so on. So so that makes sense. And the process is going to be repeated as many times as is necessary until the desired result is achieved. Let us go down now to here, where I did this question. So having gotten this 0.5, what I did next was to substitute the 0.5 into the second iteration, which is what I was just saying. So your f of x, you're substituting the 0.5 into your f of x right there. You're substituting 0.5 into the f of x right there. You get your value, you get your answer right here, which is negative 0.875. Then you're going to substitute your value into your f dash of x, which is this. And then you're going to put it into the formula, your first iterated value over your f of x over your f dash of x. You get this. This now becomes your x2 value. The 0.8181 becomes the second iterated value. So in order to do the third iteration, see here, the third iteration is going to be the second iterated value, because maybe it's a continuous flow, you know. So you can put the second iterated value, which is 0.81 over all of this. So this is a sort of many substitutions I'm talking about. So it's the same thing you're doing over and over. The same functions you're using, f of x and f dash of x, the same functions you're using. The only thing that you're doing differently is substituting different values into the function. All right? So, and incidentally, when I say different values, it means that, you notice I'm consistent here, substituting 0.81, 0.81, 0.81. And when we get this value here, 0.773223, it's going to be your third iterated value. And then when you calculate your fourth iterated value, you're going to be substituting into the function. That's all that there is to it. So the first thing to do is determine your interval. The second thing to do is to differentiate the function. Then you know the formula. When you use a formula now to substitute in order to get the second iterated value, you're going to substitute into the formula. X2 is going to be equals to x1 minus f of x1 over f dash of x1. When you substitute all of that into the function and get your value, that is going to be your second iterated value. And the second iterated value is going to be substituted into the new formula. X3 is equals to x2 minus all of that. You substitute. So you're doing the process over and over. Take time to to appreciate these different steps that you're doing, and you should be good to go. Allow me at this point to jump into this question. I think question 4 were question 3 and question 4 is what I gave you. So I've done those two. I think I sent you the solution. So just allow me to walk you through the solutions before I move on into something else. Watch me. It says, show that the equation f of x is equal to x cubed minus 3x minus 4 equals 0 has a root alpha between 1 and 3. Oh, so sir, them can write it that way instead of putting it in square brackets. Absolutely. All right. The question says, use Newton-Raphson method. Correct the 3 decimal places. Rockstone. Where Mario is, money touch base with him for me, please. I saw him by the way. He was really following last week. So you notice this one says 3 decimal places. It says 3 decimal places. So because it says 3 decimal places, I must know work in at least 1 more decimal place. If I want to work in 5 decimal places, that's up to me. If I want to work in 6 decimal places, that's up to me. But all I know, I can't work in 3. I have to work in at least 1 more. So I can work in 4 decimal places, or 5 decimal places, or 6 decimal places. All right? To find the next 3 approximations, Rockstone. The next 3 approximations. Let us go through that. I'm not going to go through that yet. I'm going to do the question and then come back to that 3 approximations. taking 2 as the first approximation, x1. Sir, how them get 2? Me not understand. The question doesn't make no sense. How them get 2, guys? Anybody saw them get 2? Because this don't make no sense to me. Taking 2 as the first approximation, x1. Anybody saw them get 2? Talk to me.
Now the
Oh,
thing
sir,
is add
it's
the 1 and the
1
3
and
and
3.
divide it by the 2. 1 and 3
So
are
that's
4. And divide it by the 2, get 2, sir.
Very good. Excellent. I said that to see if you guys were following what I was doing. Very good. So you see how they got the 2? 1 plus 3 is equals to 4. 4 divided by 2 is equals to 2. I'm finding the midpoint of 1 and 3. And the midpoint of 1 and 3 is 2. Very good, Kimali. Very good, Peter. I heard both of you coming out. All right? So that's what they get to. So this is my x1. But guess what the question says now? Find the next 3.
Therefore, 2 is equal to x1 is equal to 2.
Very good.
Cool.
Very good. So it says to find the next 3 approximation, taking the first approximation 2 as x1. So here it says now, given the function x cubed minus 3x squared, bam, 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 therefore f dash of x, remember, you know, your first, remember what Sir said? You first find the interval x1. In this question, you never have to find it because them tell you what it is. But you know how them find it. So you have x1. So the next step, to differentiate the function. You get marks right, they say, no, you start picking up marks already. You start picking up marks. Oh, I should tell you, just be careful and just make sure that your differentiation is correct here. Because if the differentiation is not correct, it means that you can use an incorrect differentiation to do the whole question. So spend some time to make sure that the differentiation is correct. All right. With that said, so I know what my x1 is, I know what my differentiated function is, I know what that function is. So I'm going to use a formula. See here? Use a formula. We know what x1 is, right? We know what x1 is. x2 is what I'm going to try to find. x2 is what I'm going to try to find.
Hold on, sir. Don't move it for a second. Hold on. You differentiate this. They're gonna drop off the 4. Get what the negative.
Come on. What we're differentiating is x cubed. X cubed is going to be 3x squared because this 3 goes in here, x squared. So this is a 3x squared.
Squared, yeah.
And when you differentiate negative 3x, we can get negative 3.
3. Yeah.
The differential of a constant equals 0.
0. Yeah. Gotcha.
Right? All right.
Yeah.
So that's what we do.
Yeah, man.
So my first iteration is given as x1 equals 2. That's what my first iteration is given as. So remember the formula. I'm using that formula and x of n plus 1. So as I go up, I'm using the same formula, but I'm just changing the values. See here? So my x2 now is going to come, x1, because in order to find the next value, I have to use the result from before, and I keep using the result. So this is why you have to be very careful, because the result that they use, the result that you get from before is what it is that you're going to be using into the next calculation. So you have to be very careful, because the next calculation is dependent on the first. It's not an independent situation. So if you lose a mark right here, so whatever the situation is, one calculation is dependent on the other calculation. Okay, so you won't get to the mark for this first step. That piece here you won't get to the mark for. Why do you think you're not going to get to the mark for it? Look at it. Talk to me now. Very good, Shanice. Very good. Because I told you, taking the first approximation as 2. In the other case, in the other example, they never told you to take they never told you. In this one here, hence find the root. So me writing this, the first iteration is 0.5. I get a mark, right? In this one here, I won't because it gave us what it is. All right. So look at what I'm doing now. My second iteration is going to be given by x2 is equal to x1 minus f of x1 over f dash of x1. This formula you're supposed to know. Write it down, etch it into your headspace. You must know that formula. All right? Watch me. Watch me. And the calculations, yes, if you look at the screen, you see I have second iteration here. Then down here, I have third iteration to show you that the calculation that we do in order to calculate the stuff is as simple as those 4 lines. Watch me. In here, I'm going to substitute my x. See here, just follow this formula. Just follow that one. The second iteration is going to be equals to x1 minus f of x1 over f dash of x1. So x1 is 2 minus f of 2 over f dash of 2. I always put in that line. Some students don't read, but I put in that line so it gives me the it holds me accountable. It reminds me of what it is that I'm required to do, so that I don't fall off track. I don't fall off track, right? So when I look at this now, I know, say, I'm transferring the information from there to here. I know I'm going to have to find f of 2 and f dash of 2. So this is my f of 2. My f of 2 is anywhere in the function given, I see x, I put 2. Anywhere in the function right? So the narrative is anywhere in the function I see x, I'm going to substitute 2. See here? Anywhere in the given function. And you know why I'm putting the word given? Because I don't want anybody to think that the function is going to remain the same every time. The functions will change. What will remain similar every time are the steps taken to work this question. So anywhere in the given function I see x, I'm going to substitute 2. So see here now, in the given function I see x. I should copy the given function too. Copy. Anywhere in the given function, bam, I see x. Substitute 2. All right? So see here now, these are the given function, you know. These are 2 cubes minus 3 times 2 minus 4. See here? 2 cubes minus 3 times 2 minus 4. 2 cubes are 8. Negative 3 times 2 is 6. Negative 6. 8 minus 6 is 2. 2 minus 4 is negative 2. I am not showing you the calculation because this is calculus 2. I'm showing you the substitution, and then I'm showing you the answer. And I will not even write it because this is calculus 2. Let me say it again. Anywhere in the given function I see x, I'm going to substitute 2. I am showing you the substitution, but I refuse to show you how it is that I calculate the stuff, because that is written on too bad. You're calculus 2, so you're supposed to be able to put this into the calculator, and your output is negative 2. All right, let's go. Similarly, anywhere in the given function, anywhere in the given function, anywhere in the differentiated function, in the, not given, but differentiated, in the differentiated function, anywhere in the differentiated function, see here, f dash of x, I see x, I'm going to substitute 2. Watch me. 3 times 2 squares minus 3. See here? 3 times 2 squared minus 3. 2 squares are 4. 4 times 3 are 12. 12 minus 3 are 9. All right? So now that I've evaluated those two, I'm going to now substitute it in the formula. Right? No SUB. Right? I'm now substituting to give in the formula, and the formula says C to suppose 2 minus C the same 2 minus, and then now f of 2 works out to be f of 2 works out to be oh, come on, don't do this to me. F of 2 works out to be -2. F of 2, see here? F of 2 works out to be -2. That's why I have the -2 up here, so. All right? And then f dash of 2 works out to be 9. See here? F dash of 2 is 9. So I put it down here. So this is what I'm going to work out now. 2 minus -2/9. And I'm going to get 2.222222222. This is now my x2 value. This is now my x2 value. To do the third iteration, remember them say must do 3 other iteration, you know. My third iteration now is going to
But
be
how much decimal point they said to give the answer in?
2.
2? Oh, 3.
No, 3 decimal places.
So you should have go up more with this one.
So yeah, so you're right. You're right, Shans, but I made a mistake right here. You see in the other one I use 4.
Okay, sir.
Look at that. You see what I use 4 right here, so? So
Yes, sir.
I should add another one here. You are correct. You are correct. One Shanice, Bob. All right, so you're correct on the bunches. So I decided to use 4 instead of using 5 or 6. All right. So the third iteration, I'm now going to show you what I do right here so again, because now that you see it, are the same thing we're doing over and over and over and over again. Watch me. In the second iteration, I had x2 is equal to x1 minus f of x1 over x1. Is it any value right here, so? The x1 right here, so? I'm going to be the same x1 I put in right here, so. At the same value, I'm going to put here, so, yes, so, and yes, so. And the x1 can't be the same thing as x1 because you try to find one, the other one above this. So this, if we're talking about if this is x3, this have to be x2, this have to be x2, this have to be x2. Watch it. See here? X3, this is x2, this is x that, this is x that, because this is going to be one less than the one out here because you're trying to find the next one before it. So come you read this. So you notice this is x of n plus 1. This is 1 more than xn, xn, xn. All right. So in the third iteration, and the subscript tells you what iteration you're calculating. You notice the second iteration. See, the second iteration is x2. The first iteration is x1. So you can look at your answer and know which iteration you're in. So in the third iteration, you're going to have your x2, 2.222 minus f of x2 over that. F of x2 is where I'm going to substitute 2.22 into the original function theta, so f of x, and I'm going to substitute 2.222 into the differentiated function. I mean, now write it again, sir. Why not write it, sir? Come and write it up here, so you're supposed to know what I talk about. All right. So I'm going into my function, my original function, and anywhere into my original function, any 2.1234. Anywhere into my original function, I see x. I am substituting 2.2222. See here, 2.222 cubed minus 3 times 2.222 minus 4. All right. Now, when I substitute all of this into the function, look at what will happen. I'm going to get my 0.3070. 0.3070. Again, I'm now show you how to put this in and raise it to the third minus that. This is calculus 2. You're supposed to know how to do that. My f dash of x, remember now, my f dash of x not changing. My f of x not changing. Those are constant, right? So all I'm changing is my substituted value. All I'm changing is my substituted value. So I'm now substituting 2.222 into my differentiated function. And when I do that, I'm going to get 3 times 0.22222 squares minus 3. My output is going to be 11.8145. When I get that, I have the f of x. I have this. I have this. I may know this. I put it into the function. See it right here, so 2.22222 minus that piece up here, so over that piece on here, so I'm going to get 2.192. Right? Now, watch me. I don't finish it, you know, because it said it must use the next 3 iterations. But watch me. I'm looking at my answer to see if I'm close to where I'm supposed to go. I start off with 2. My second iteration is 2.22. So it looks like the value going up. And to 3 decimal places, it is really 2.222. To 3 decimal places here, it is 2.196. Can I finish here, sir?
No, sir. No, you have to repeat first.
But tell me why. Very good, but tell me why.
Because then you would have found, you when it repeats, that means you have found the general area.
Very good. So because this value here is not the same as this value, it means that I can go to another iteration. All right. So watch me now. But
Sir,
yes,
is
sir.
it
Yes,
okay? Sorry. Let me rephrase. You continue until the 3 decimal places are constant.
Same difference, same thing said. I
Yeah.
understood what you said the first time. Now, the truth of the matter is, because it's not the same, we want the exact value, you know. So we have to go to our 4th iteration. Sir, so much time. I will ask the question carry. So let's go. The 4th iteration is going to be x3 minus f of x3 over f dash of x3. See here? This one is going to be one more than what goes into here. So because you're trying to find the next iteration. So we have, in order to find the 4th iteration, we have to use the 3rd iteration in order to find the 4th. So that's why inside of here is going to be x3 and x3 and x3. You can't have x3 right here, so, and then have x2 right here, so, and x2 or vice versa. Whatever you put in right here, so, have to be the same value that you put it. Hold on. I think I hear garbage truck. And I may have a mini river ton on my yard, you know, because a long time they may come. If it is them, I have to go pause when I run go to door here.
Yeah, man, we're not a problem with that, sir.
Cool. So
and you can give the man them money and make them take it up in there. You have to be such a miser, you know, sir.
No, man, garbage truck. When them come on my yard, man, them still long, because they want water, they want money, they want everything. All right, let's go. Hold on. No, it'll drive too long for the garbage truck. You have to stop, and nothing for it. All right, so remember now, this is x to the 4. Sorry, not x to the 4. This is x subscript 4. This has to be x subscript 3. The point I'm making is you can't have x3 right here, so, and then have x2 or x1 or vice versa. The same value that is here, x3, is going to be substituted into the function to get another value. Substituted in f dash of x to get another value, but it's the same value that is here. You can substitute into the original function and the differentiated function. Let's go. So see, this is what it works out to be. 2.1962 supposed to be substituted in this f of that and f dash of that. So let us do the substitution. This piece, f of 2.1962, when I substitute it in the function, I'm going to get 0.0040. Hold on 1 minute. All right, so it's going to be now 2.1962 all cubes minus 3 times 2.1962 minus 4, and the output is going to be 0.004319. Let me just stop share and reshare, please, to get rid of that annoying little box. All right, so you're going to get that. Then now the f dash of x is exactly what I'm going to be doing, but I'm substituting it into the differentiated function. So we have 3. Remember, the differentiated function is 3x squared minus 3. So anywhere in the differentiated function I see x, I'm going to put in my value, 2.1962. So 2.1962 squares. Remember, you can't multiply this 3 by this first and then square it after. Bomb-das. So I have to do the 2.1962 squared first, then times it by 3, then minus it from 3 is 11.4699. So having evaluated this and this, I can now substitute it for this value up here and this value here. Notice that this value is going to remain the same. See it here, so. This 0.004319 is right here, so. And this 11.4699 is from right here, so. When I substitute that value here, so, I'm going to get 2.1958. Them said they wanted to 3 decimal places. Hold on, they know. Let's just check. 2.19 to 3 decimal places. What is work out to be 3 decimal places? I don't remember how to do that. Let me get this to be 3 decimal places. What the answer would be for 3 decimal places? What will this be for 3 decimal places?
196, sir.
2.196. All right, let me check this one. What is going to be to 3 decimal places?
Sir, 2.196.
Rockstone. So it means that two of them are the same, don't?
Yes, sir.
Do I have to go any further?
No.
No,
No.
sir.
All right. So what
No.
am I saying now? You will see that to 3 decimal places, the result is of alpha is 2.196, which is exactly the same for the third and fourth iterations.
Sir, we have to write that, sir?
No, me just I tell you, because I'm a teacher, me I tell you.
Okay.
Right? But you're supposed to know this, do you know?
Yeah,
Right?
man.
Right?
That's the first thing sinking. Come, you want to know how far for work because
Absolutely.
I say a whole heap of work and how far them want me to do this thing.
All right. So when you reach something, but look at the question now. You think the man them is smart? Or what could the man them say to you? Find the next 3 iterations.
Oh, so that means they know that it's 3.
Very good. So the question I help you out. The question I can't be 15 marks, you know. Can't be 15 marks because them give X1 and they might tell you how much we go down to. Because the man them know the question, you know. Them do the question already. And the man them say, take X1 to be 2. Matter of fact, find the next 3 iterations or the 3 approximations. Now, the mere fact that them give you X1 don't mean say they stop at X3. Because if them give you 1 and them say to you find 3 more, them give you X1 and them say find 3 more. 1 and 3 are equal 4. So you have to go to the 4th iteration. So anybody who decides say them are going to stop at X3 because them say X3 would not have gotten some of the marks. So you have to read the question. That's the point I'm trying to bring across. You have to read the question in order to do it. But let me tell you what Sir did a while ago. I don't know if anybody pick it up. When I got to my 3rd iteration, I stopped and I said to you, check to see if to 3 decimal places, if this was equal to this. And some students said, most of you said, no, sir. So you know you can't stop because you don't reach a solution yet, right? So if you don't even know what them did mean by the next 3 iterations and you only stop at this, because the 3rd is just a cardinal point, which means 3, right? So when it says 3rd and 2nd, it's really talking about the placement, right? So when you come first, which is a cardinal position, it means that you're in the number 1 place. When you come second, which is a cardinal point, you are number 2, right? So the cardinal points are just showing you the position. So when you reach a 3rd point, you'd recognize it, me can't done because the piece I left to come out because these are only 0.222 and that's a 0.196. So you have to go to the 4th one. And the 4th one, when you look at it, you see that it's 0.2196. Sorry, 2.196 to 3 decimal places, 2.196. The question is done. Question is done right there. As I stop.
Sir, so this would not be 15 marks, right?
About 10 marks. About 10 marks. And 10 marks are still enough marks.
No.
But my question to you is, I know quite a number of you understood this last class. Having gone through it again, is the understanding a little bit clearer to you? Is there something that you want me to go through? I know I have one other question, well, 2 other questions to look at. I am going to take the time to go through those other questions because when I finish it, you know.
Done.
Is there something that you're not seeing that you want me to just talk about?
Oh, sir, Macintosh reaching us, sir.
Okay, so all you reach and say good afternoon.
I didn't want to disrupt your explanation.
Okay, sir. Good afternoon, sir. Andre.
Good afternoon, sir.
Anything when we say a while ago, you catch it?
I just get your last part, but I would. If you're going to share this document, I can follow and ask you questions and shoot your email if anything.
I'll think about it. All right, welcome, Papa. All right, so let's go. So now, having gone through these 3 questions, let me just pause and let me go back to the summary that I just put in. Where so much work to do? Rockstone. All right, let's just pause and go back to the summary that we just typed. You saw me type this summary just now, right? Let's go. It says, first, in order to do the Newton-Raphson, we need to first determine the value of the first iteration, right? We need to determine the first value, rubbishness. We need to determine the value of the first iteration by finding the midpoint of the given interval. So, Let me just put in something here. I put in if not stated. You remember the question about just a while ago, them stated, right? So I don't want anybody to think that you have to go find it. So sometimes they give it to you. Like example 3 a while ago, they gave you the first iteration. They gave it to you. But if they don't give you, you're going to have to find it. But how you find it, sir? You're going to determine the first iteration by finding the midpoint of the given interval, if it is not stated, right? Now, when you first do that, that's the first step. The second step is to differentiate the function. The next step is to differentiate the function. So when you differentiate the function, you can hold those two. The next step is what is going to be tricky. When you do step 1 and step 2, after you do them something here, then they're done, you know. This is what it is that is going to be very monotonous, because you're going to repeat the process so many times. It's it here. Use a formula. This to determine the first iteration in order to obtain the second iteration, and so forth and so on, right? Because we're going to use the second iteration in order to determine the third to determine the fourth to determine the fifth, so forth and so on. That's what it means. Note, you will be required to make the several substitutions. That is, f of the first iterated value and f dash of the first iterated value. Does that make sense? What it says is that you're going to put in your x1 into your original function f, and you're going to put your x1 into your differentiated function f dash of x. And when I say and so forth and so on, copy, paste, f of the second, second, of the second iterated value, and f dash of the second iterated value, second. All right. So what I'm saying to you here is, I'm going to put my x1 into my original function and my differentiated function. When I get the second iterated value, I'm going to put it into the same function in the same. So you notice this is the same thing. The first iterated value, the f and f dash of x of the first iterated value. Then I'm going to put in the same f and the same f dash of x, the second iterated value, and so forth and so on. All right. And then the process is going to be repeated as many times as is necessary until the desired result is achieved. And that follows from this third step. So this fourth step is no longer necessary for me to have there, because this and so forth and so on takes care of this as many times as necessary. But I'm going to let it stay there. All right. Now, Macintosh just joined. I have one other question from the handout that I circulated before. I will recirculate this one, of course, because I would have made several adjustments to it. I want your undivided attention. I know it's a Saturday morning. I may be looking after breakfast and have some chores to do, and you're multitasking. But remember, when I move on from this, this is it. You better seal it. Control S. Save it. Let's go. It says a function is given by f of x is equal to 2x squared minus 3x minus 5. With x equals 2 as a starting point. What do you mean by that? X equals 2 as a starting point.
So this question is given as well.
What is given?
The first iteration is given.
Okay, that's exactly what it means. With x2 equals 2 as your starting point, it means that x1 is equal to 2.
All right, sir. What I think you should make note of is if the first iteration is not given as a starting point, the coordinates will be given, right? Yeah,
that's what I said. I said it.
When did you put it write it at the top? Did you say if you said it has to be worked out? I think
if not stated.
or if not stated.
Right.
But how would
So
you work?
sometimes, see here, hey boy, pay attention. Look
What's
here.
wrong with you?
See, Shanice was the one who asked the question. See, right here.
Brother, me I make sure say this thing bulletproof,
Yeah,
you know, man.
yeah, me know, but me want to work with me. So Shanice did ask, and Shanice said, "Sir,
Oh,
you
yeah,
can
man,
colorize it." Yeah,
Yeah,
man.
yeah.
So I colorize it right there. So hey boy, just pay attention, man.
Oh, I thought you would put it in the summer too. All right, but it's
No,
okay.
you don't need to
Fine.
put down the summary, man. That go there. That there. Where are we? We're right here. So good. So x equals 2 as your stated point, as a starting point, Rockstone, stated point, as your starting point. That means that x1 equal 2. Use Newton-Raphson method to write 2 iterations. Oh,
Just 2?
just 2 to find the approximation of the positive root of that. But sir, that question I don't give you no interval. Hold on there, sir. The one up here, so them tell you say alpha lies between 1 and 3. But them tell you which one to use as the first, which is x1 equals 2. That. But the one here now, sir, it not tell me no interval. Let me read the question again. A function is given by f of x is equals to 2x squared minus 3x minus 5. With x equals 2 as your starting point, use the Newton-Raphson method with 2 iterations to find an approximation to the positive root of f of x, which is equals to 2x squared minus 3x minus 5. Give your answer correct to 2 decimal places. Sir, it not giving no intervals. Do I need the intervals, class? Tell me.
Yes, sir.
No, I don't.
No, because them give you the
No, because
point.
it's at already equal to.
Yeah,
Yes,
tell me
sir.
that.
So, but that would be, but sir, when I say
Uh-huh,
yes, sir, mean
uh-huh.
that it is already there.
No, man, but the question I was asking is, in addition to giving my starting point, if I need the intervals, it's like what they gave me the interval here between 1 and
Okay,
3,
sir.
but they
Okay.
give me the
I
starting point.
see
I
what
don't
you're
need it, right?
saying.
So in this case, I don't need it. I don't even know. I don't even want to know where it lie between. No, mark you. I
Want them
can
give
guess.
it, you know, sir. You know why them
No.
want them give the interval? The question will be for more marks. So that's my point, you know.
Okay, fair enough. But you know what we can guess? Is it because x equals 2 and we normally use the midpoint? Do always have to happen. Remember, when I say between 1 and 3, I don't know who asked the question last class when we had our first class. Sir, how do we know which value to start off with first? And I said to you, normally a good starting point is to use the midpoint. So I say to you that a good starting point is to use the midpoint, because what I don't want students to do is just, and this is why the questions give you what it is that they give you, because if they said to you between 1 and 3, then they want people to start at 1.5 instead of starting at 2. Because start at 1.5, you'll get the answer, you know. You'll get the same answer, but guess what? You have to go down to many different iterations. And you don't want that. So you want to make an intelligent guess. Remember, you remember, see to yourself, initial guess. Initial guess. So remember last week we were talking about the FBI looking for the lost child. The child was last seen in Kingston. You don't want to start from Montego Bay. You will eventually find the child, you know, maybe dead. So what it is that you want to do, God forbid, but what it is that you want to do is to go as close to your end point as that. So when Everton said, no man, me see that here the man, I see the child, I can tell you because the child looks so much like my cousin. And when you show them the picture of your cousin, say, yes, that's exactly how the child looks. Where did you last see the child? In a vineyard town. So my starting point is going to be in vineyard town, right? So you're trying to get your starting point as close as possible to what it is that you're looking at, and which is why they are giving you the starting points. Watch me now. Ouch. So remember the first thing to do, the immediate given function, you have to differentiate the function. So let's go. What is the differential of this function f of x? Don't all rush me.
Sir, we have x equal, f of x equal
Dash of x.
4x minus 3.
Okay, thank you, Peter K. But can you say f dash of x, please?
Repeat.
Can you say f dash of x? You said
Okay.
f of x.
F F dash of x
Mind your bite your
equal.
tongue. Mind your bite
Shut
your
up,
tongue.
Everton.
Is equals to?
4x, yeah, minus 3.
Very good. All right. So let me tell you why. Let me tell you why I corrected Peter K. Because Peter K said f of x. There's already an f of x. We don't want to get confused with our f of x's, right? So the correct thing to say is f dash of x, and you are correct. Very good. Remember, students, what I'm going to do for the second part of this class is to spend a little time on differentiation, because if you don't know how to differentiate, that will suffer. All right. So let's go. And they told us that x1 is equal to 2 from the question, with x using x equal to as a starting point. So that means my starting point is x1. So my x1 is going to be equal to 2. Now, look at my formula. The next thing we're going to do, is to look at the formula. See here? Formula. Because after I identify the given function, and after I differentiate the given function, I know what my x1 and the first iterated value is going to be.
How much marks we get for the differentiation?
About 1 mark. You know, I get no mark for differentiation, man.
I can get 3.
No, man. Matter of fact, they're good at me giving a mark for the differentiation, because I'm supposed to know, you're supposed to know to differentiate. Let's go. So my second iteration now is going to be x2. Sir, or you know, second for 2, third for 3, so fourth and so on. So my second iteration is going to be x2, which is equals to my x1. Remember, you know, it's going to be 1 less than this, x1 minus f of x1 over x1. So anywhere in the original function I see x, the function here, I'm going to put in 2. So it's supposed to be 2 times 2 squares minus 3 times 2 minus 5. 2 squares are 4, 4 times 2 are 8, 3 times 2 are 6, 8 minus 6 are 2, 2 minus 5 are 3, negative 3. See here, so I get my negative 3 right here, so. And if I go right here, so I'm putting 2. 2 times 4 are 8, and 8 minus 3 are 5. So I get my 5 right here, so. I am not going to show this class how to evaluate the stuff, the steps in evaluating this negative 3 and this 5. This is calculus 2. So having got my x1 value, my f of x2, this is supposed to be 2. Let me just put it there so that you can follow what is happening. Come on. I am going to now substitute all of this. This f of 2 is going to be 3, negative 3, and this f dash of 2 is going to be 5. So it's going to be 2 minus negative 3 over 5. See here? 2 minus negative 3 over 5, and I'm going to get 2.6. I'm going to get 2.6. Now, the question told me to find 2 more iterations. The question told me to find 2 more iterations. Watch this. This is my x2 value. So my third iteration is going to be x3. Remember, third is a cardinal point for the value 3. Third, fourth, fifth is just showing you the position. Think about when Shelley and Fraser Price run and she comes first. Think about what's her name? Elaine Thompson run and comes second. And think about Shericka Jackson run and comes third in the 100-meter finals at the Olympics. And Jamaica get gold, silver, and bronze in the 100-meter. And think of them getting gold, silver, and bronze again in the 200-meter. That's my prediction. But anyhow, let's go. So the third is for 3. Watch me. Oh, sir, I see what it is that you were saying in the previous question, that my second iterated value is going to be used now to substitute into the function. So one function depends on the previous function. Thanks for seeing this. So this is 2.6 minus f of 2.6 over f dash of 2.6. Anywhere in the original function, I always go back to my original function, and I always go back to my differentiated function. The only thing that will change is the value that I'll be substituting. In the first instance, I substituted 2. See it right here, so? In the second instance, I'm going to be substituting 2.6. Oh, sir. That means, sir, 2 wasn't so close to the value then, you know, sir. Why you say that? Because, sir, the first iteration jumped by 0.6. Very good. You notice in the first example we did, we got 2. And the next iteration value gave me 2.222. That was much closer than jumping all the way to 2.6. All right, let's go. 2.6, and when the original function I see x, I put 2.6. My result comes out to be 0.72. And we're into the differentiated function I see x, I'm going to be 2.6. Putting 2.6, I'm going to end up getting 7.4. Into my formula now, I'm going to have my 2.6, and I'm substituting my value of f of 2.6, which is 0.72 up top here, and I'm substituting my value of f dash of 2.6, which is 0.74 down here. So, and then I put it into the function. I'm going to get 2.5027. Oh, sir, to come back down. Yes. Sir, why did it come back down? Because 2.6, they just passed the iteration, the exact value. So it's coming back down now. Oh, sir, that means say the answer will be between 2.5 and 2.6. Make we try it now. So we're going to go to the other iterated value. But you know what, sir, they do? Your loving teacher went through the fourth iteration and did the fourth iteration and got exactly 2.5, which is what I got right here. So technically, because the question did say to 2 decimal places. And when I did the question and got 2.5, I said to myself, why don't you read the question, Mr. Shan? And I didn't erase it. And I went at this day because I want to show you that sometimes the teachers do make mistakes, right? I didn't change it. I'm going to tell you why I didn't change it, because I wanted you to see what is happening. Look what happened a while ago. Look what happened. The question says, use x equal to at the starting point, 2 iterations.
Oh, so that means you should have stopped when you were at the
X3.
third iterator.
Very good. Right? It says Newton with 2 iterations. So them give it the first iteration. And I'm supposed to do 2 iterations. So I'm supposed to stop at X3. Me never read the question properly. I mean go up to the 4th one. Sure, so would you lose marks? I wouldn't take off any marks because you'd end up doing more work. And you'd have said the answer is really 2.50. But I left this here for you to see my error. All right? So your answer here
Sir,
is 2.5.
oh, you get the line, go through it, sir.
This? Me just
Yeah.
cross it out. Me just cross it out.
It's still
You
not
just cross
answer
it
my
out.
question.
Which line are you talking about? Right here, sir?
The line that crosses it out through the middle.
Oh, is that let us go through the cross out something, the strike through icon on the
Oh.
yeah.
All right.
Yeah.
Good.
Yeah. So this here is not a part of the question because they never asked me to go through 3
Sir,
iterations.
sir,
Yes, sir. Yes,
It's
sir.
valuable. Leave it alone, sir.
No. I'm leaving it. All right. We're done. Finito. Andre, unmute for me, please.
Yes, sir.
All right. How was that?
Yes, I followed the formula and the steps. I was going to say when for your 4th iterations, if we didn't go to the 4th iteration and what you'd say round up or just assume that once it is 2.507027, we just assume it's 2.5, and then if that answer would be accepted if we show that we just said rounding up.
Absolutely, because the question did say give your answer correct to 2 decimal places. So I would have had to round off this to 2 decimal places to give me 2.5. So
Okay.
yes, you are correct. All right.
Sir,
Yes, sir.
which other thing you say I gotta do today?
I need to go through some differentiation.
Alright, mad thing.
I need to go through some different. What time is it now? This is now 10 o'clock. All right. Let me just sort out my.
Sir, here we are. Let's go through the differentiation and then you got introduce whatever that come after the differentiation at the end. You introduce that, sir. Give you an example. I make a model through it and then you go over it at the start of the next class, and we'll move on.
No, you're crazy. So what I'm gonna do is I'm actually trying to find the soft copy version of the Calculus 2 exam last semester
Ooh.
to show you to give you rather to give you the Newton-Raphson question to do in class today.
Sir, my I crashed my machine crash, you know. I must have me do it. I could have give you.
Oh yeah.
But
yeah,
nobody
yeah,
else,
that's true.
nobody now have it download to the machine. What do the last test? Or
Yeah,
download it off or something there. Anybody have it?
No. You know,
Off of Canvas.
no man. Remember the detail on Editors Office. You're not gonna be able to download.
What?
You're not going to be able to download unless you're going to take a picture of it. But it's alright. Don't worry about it. I will get I'm almost sure that I got it. So what I'm going to do in the meantime, while I look for it, is to
Oh yeah, true.
when was the exam? The exam was in.
I think it was the 7th
It was in June, don't?
or the 13th.
No, it's not in here. So it's reach March. I'm gonna see it. All right, let me find, check my email. All right, let's go. So we need to move into some differentiation, and I am going to talk about the exponential function. Now, when you look at your syllabus, and it is important, guys, it is important. Let me just project your syllabus. It is important that you go through your course outline. Course outline for 4702, Calculus 2 is here. So stop share, and let me just create a new share. Sorry. All right, so when you look at your syllabus, let me see if I can, that comes up on search for this thing. Now remember, you know, some of you may say, sir, you're moving too fast, but it's not a matter of moving too fast. It's a matter of me trying to give you a good opportunity in passing the course by completing the stuff, even though I would have submitted my,
Sir, do you have the information for the masters? They can forward it to me.
I don't have it. I don't have it. I could try and get it, but I don't have it. All right, look here, guys.
Let us email Ms. Campbell. Sorry.
Yeah. All right, look at this, guys. All right, so look at this. That's your Calculus 2. See it up here, Calculus 2, 4702. And come on, don't believe this to me now. All right, so in Unit 1, I have completed number 3. All right. In order for me to do number 3, I had to do a review of differentiation, which is what we did for the first half of last class. I had to do a review of differentiation. So I did differentiation. Then I started at number 3, numerical methods, Newton-Raphson. All right. So I did that. Today in class, I'm going to talk about the differentiation of exponential functions. So we're going to be looking at the differentiation of exponential functions in class today. Then after going through a few questions on the exponential functions, I'm going to, hopefully I can find this past paper on this one, last year's past. If I can't, I'll just move on to something else and send the question when I find it for you to do in preparation for next class as a review. And then Maclaurin's theorem, and this Maclaurin spelled wrong incidentally. Maclaurin's theorem for approximation function with infinite series is another easy topic that I'm going to introduce today. When I say easy, all you're doing is differentiating and substituting, differentiating and substituting, differentiating and substituting. Easy 1, 2, 3. I'm going to be using, this is now 10 o'clock, I'm going to be using 10 to 11 to do the differentiation. So I'm going to, the differentiation of the exponential function. I'll also spend some time doing differentiation of other types of functions. Because when you get Maclaurin series, sometimes the Maclaurin series comes with a product. It may come with a chain, it may come with a quotient. So you have to be versed on those differentiations. So at the end of today's class, I'll pretty much finish 3, 4, and 5. Small increments are something we can do in about 15 minutes. We're not even pay this no mind right about now. And just work with it, guys. I am trying to be very strategic in getting some of the big boys out of the way, if you follow what I'm saying, right? The small increments I'm not worried about that. The curve sketching, I'm not even worried about that either. Really and truly, I'm not worried about this. All right? Really, I'm not worried about it. All right? And trust me, when I say I'm not worried about it, believe me, I'm not worried about it. I can even send you something on curve sketching, right? And in small increments too. Not worried about those two. And then applications to integration, I would want to go to the trapezoidal rule first. That would be next class, of course. I'll go through the trapezoidal rule, and then having gone to the trapezoidal, because we're meeting for 4 straight hours, I use half of the class to do the trapezoidal, and then spend some time on calculating the volume, right? Rotating about an axis. And then, you see, come back again, integrate exponential functions, and talk about the intermediate value theorem for exponential functions, for integration. So this is really not bad. This area is not bad. And then third one, FODE, first order differential equation. Love this. Really not bad. Then the fourth one now is going to talk about multivariable functions. This is the longest part of the syllabus. Look here, 11 different things you have to go through. This is the longest part of the syllabus. And then the fifth one is just introducing calculus software that I will go through with you. All right, Excel, etc., right? So there's something can be finished. Now, so I'm being very creative in how it is that I'm going to be attacking this fast track. Remember, there will come a time when I say students want to cook early so we can spend a Sunday afternoon to go through some stuff. When that time comes, I am a Sunday worshiper. So when I give up piece of my Sunday reflection afternoon, it is because I want the best of you. So when I say, guys, I won't tell you it's going to be every Sunday. It won't be every Sunday, right? So one of these Sundays I may come and say, come to spend 4 hours, or 3 hours, or 2 hours, whatever the situation is. You can eat your dinner in a class, and we can sit down and we just relax, and we just work through some stuff. Because hear me out. If you plan to fail this course, log out now. Now come back on the class. Please, I'm going to ask you to give me your 100%. I want you to press equal, me say 50 plus, so you can pass the course. I'm not even interested in A's and B's at this point. I'm interested in you passing the course. All right? So let's go. So I show you this to show you that I am going to be moving. I am going to be moving. When I tell you that it is not difficult, I'm going to tell you it's not difficult. Let me just say something right here, so because I was very disappointed with my group in doing this particular question last time it was given on the exam. And I remember only one student in the class did it and got full marks for the question. One student who did it and got full marks for the question. There was another student who did it and got quite a number of marks out of it. But for the most part, the other students would have gotten like a 1 mark or a 3 marks. I think that question came for about 8 marks, if I'm not mistaken, about 8 marks, yeah. And one student picked up the whole 8 marks out of it. The other student maybe picked up about 5, and then the other students, some pick up 1, some pick up 2, some pick up 3, right? That is not difficult. And based on the time that I spent in class, my class last time around to do that topic, I was very hurt when I marked the papers, right? So it says to me that there was something that was missing in teaching that topic. So I'm going to come with a different approach this time around, all right? Just to see. All right. So now, stop share. Now I am going to, it's now 3 minutes past. Let me go through exponential functions, differentiation of exponential functions, e to the x, e raised to the x power. I'm going to say this and say this once initially, and then I'll allow you to sit and think about it. Very profound. The differential of e to the x is e to the x. Can you see that for me, please?
When you get paid, pay your bills first.
Okay. So the differential of e to the x is e to the x. It can't get any easier than that. Matter of fact, I'm going to even jump into a piece of the integration and say the integration of e to the x is e to the x. So e to the x has its own differential. It also has its own integral. So what do you mean by that? All right, thanks for asking. The first rule is to recognize that the differential of e to the x is e to the x. Watch me. Y is equals to e to the 1x. We never normally write 1x, but I just put the 1 here because I want to bring across a point. I want to bring across a point. The differential of e to the x is e to the x. All right? Now, see it so? E to the x of, let me use my spotlight so I can show you what I'm talking about. See it so? E to the 1x, or e to just simply e to the x. All right? Now, e to the x. You see it right here, so? E to the x. Everything right here, so. Everything right here, so. Everything right here, so. Is the same as everything right here, so. Talk truth. Let me see if you see that. Yes or no?
Yes, sir.
Yes,
All
sir.
right, hold on. I'm a want them to pay attention, you know. Because I'm sorry. I have to stop the class to ask you this. I have to stop the class to ask you this. All right. So I am locked away into a room having this class. Me, Jesus, and Una alone in the room. Somebody just walked in and handed me a bag. And I remember, you know, with something that I once was gifted with. When I ever put on, we wear one pants and put on money in the pants and I know, and when I wash the pants and put on the pants, and the Spirit of the Lord, they say, wear that pants on a day when you are broke and you put it on the pants and find the money. It ever happened to you?
Every time.
Yes,
All the time, sir.
Yes,
all the
sir.
time.
And when you find it, you're the happiest person ever because it's up on your face.
All
Sir,
the
only for
time.
$50,
Me say,
sir.
only for $10, it make a difference. Trust me. So it's not money this time, you know. It's just a gift that I was given, and you know, I didn't remember the gift. And the person just walking and just handed me the bag, and I look in the bag and I just started to smile because I'm saying to myself, just look at that. We could have so it's just one of those things. Anyway, that was a break in transmission just to get you to refocus. So let us get back to this now. Watch me. E to the 1x. That e to the 1x here are the same e to the 1x right here, so. All right? Continue working it. Sir, but I want to come from you and leave that alone. Don't worry about it yet. Let us go back here, sir. You see e to the 2x are the question, don't it? Say yes.
Yes, sir.
You see e to the 2x right here in the question, in the answer?
Yes, sir.
All right, watch it again. E to the 3x, you see it? And you see e to the 3x in the question, in the answer right here, sir? All right.
Yeah.
So it supports the point that it supports the point that is better me done this. Suppose you can write a book.
We will tell you that, sir.
All right, because I am teaching you this as if you were in front of me face to face, so that you can understand. And I will send copies of this to you. So fret not. All right. So let me just carry this down here because I didn't remember that I have this down here. All right. So and let me just go through this other one. Look at this. E to the x squared. Can you say e to the x squared in here, so again?
Yes, sir.
Yes,
And this
sir.
e to the blow, sir. E to the 3x squared plus 5x minus 7. See that, sir? E to the 3x squared plus 5x minus 7. So therefore,
Hold on, sir. Number 4. Number 4. Oh, all right. Cool.
Mm.
so therefore, this supports the point that the differential of e to the x is e to the x. Full stop. It supports the point that the differential of e to the x is e to the x. Supports the point that the differential of e to the x is e to the x. All right? Oh, Lord. Again, it comes back to this.
Sir, you don't have a problem if me record your video them and we start a YouTube channel.
We can talk about it. You know, one of the things that I'm going to take to this class sometime later. A matter of fact, let me just say it for 2 minutes.
It's going to be
Just 2
under
minutes.
it's going to be under my name still, sir. So the funds come to me. Me give you wallet,
whatever.
sir. Me manage it for you. Me manage that, sir.
Hear what a thought came to mind, and I said that I was going to talk to you guys about it. So, you know, it's just divine intervention.
Why you asking us if you're a better teacher than most of that? Yes, sir. Yes, sir.
No. And this is where we can get a little bit of our you know, some differentiated funds flow. Oh, master. One of the things that I'm really thinking of is to create an app. And I'm just going to say this for 2 minutes. I don't necessarily need to get a comment just now. It's just for you to think about it, and then we can have a conversation after. So in my headspace is I want to create an app for the math department. I wouldn't even say for Express or Community College, for the math department, as the head of the math department, so that, you know, it is embedded within our ECC website. So for example, Shanice is given a question, e to the 1x. Shanice can log on to this app to say, good day, I am doing this question, and, you know, the app comes with a little, you know, typing equation editor, whatever. She types the question there, and she writes to say that she does not know how to do it. Now, either Mr. Shand or whichever other lecturer within the department who has,
Answer.
Me not in a deal with you know, from morning I ask you.
Sir, we did have to sort out some things, sir.
No, but you can't do that, Virgin. At my expense, 2 hours, 2 hours and 11 minutes.
No. Sir, but when you said apologies are early, you know.
Me never see it, so me still cut you off. You know much time? listen, ask them in another class how much time I ask to remain. Not enough time. No, I'll cut you off, man. Right. So this is what I want to do. So any member of the department can pick it up and can say, we don't even have to know. Well, we say, dear Shanice, just remember that the differential of e to the x is e to the x, and then the teacher, the person on the other end can send some other questions. You know, we can even type on, matter of fact, how I would want to do it, I would want the students to type. I would want it to be, you know, using the keypad where it is that you can actually write the question or the function. So I can be on the go, having dinner, and see this thing comes up, and I recognize that, say 5 of us have access to this, and none of the 5 members are, you know, answering the question. I say, you know what, let me just answer it. It's an easy question to answer. And I tap the response, and I say to Shanice, okay, Shanice, dear Shanice, just remember that the differential of e to the x is e to the x, and the differential of e to the x is e to the x. And sure, I'll look at 1 or 2 other examples to say this is what is that and that, and send it off. Now, if Shanice has another question, like question number 5, then she may know that she was speaking to me. So she may say, okay, Sir Shand, so what if you're given a question, y equals e to the 3x squared plus 5x plus 7? It may not be Mr. Shand that picks up that question, because maybe Mr. Shand is in a class or is just unavailable. But somebody else who comes and picks up that question can actually see the thread and see when Mr. Shand would have responded to Shanice previously, and then can follow through, and then this other person
Sir.
Yeah.
Stop. Hold on. Slow down. First thing is first, ECC websites already has something like that built into it. It is called that little chat window that chat to somebody, that little thing that pops up. All they would have to do is then make another page that is connected for this app that you're talking about, and then run that same pop-up message through that window. You get me? Because with every problem that someone uses on the chat, it is stored in a database, and once you are signing up for the chat, so you go on and you said, okay, your student ID number or your
first name, last name,
email address, and whatever, right? And then based on that, then they would get, based on their credentials, they would get access to the platform, in the sense that you have to use your ECC email, correct? Right? And your password. And or they could use their same ECC email and password that they use to log on to Arian or whatever. Once they use that and log on, that chat feature that is on the original page can be used same way for this. The only thing about it that they would have to change is the keypad.
to allow them to use those signs and all of these niceties and whatever. That's the only thing that would have to change. So that is already, the infrastructure for that is already on ECC's page. It's just for you guys to utilize it.
All right, and that's it's just a keeper because we have to go put in. Remember my condition, conditionality to it. Some students don't know how to type math stuff, so I would want it to have a keypad.
All right, so that keypad, those keypads are actually plugins that you can put on it.
Great.
Literally.
Right.
So those things are already made.
All right.
The thing about it is that it's for you to design how you want to get your information across to the student. And you need to stipulate that you need for it to be linked to ECC's
database.
Student database.
Yeah,
so
yeah,
the directory service. So it can recognize that yes, this is an ECC student, they have ECC credentials on it. That's it.
And great. So that's where my thinking is going as head of department. So that we're, and I don't know if for something like this, you guys could find it very useful because you will know that.
Oh God, man, sir, yeah, Bill said when me left, and that'd be a stress one.
All right. So that's where my thinking is. So when you hear me come to you guys, you can leave your legacy, Everton, because I mean, I can say Everton Kelly, assisted in this sort of stuff, So I will come back to this group. I will come back to this group to talk about it so I can fine tune it because I want to put this in place come September morning. All right. So I will come back to this group. All right, let's go. So now I have just shown you that the differential of e to the x is e to the x. I did 1, 2, 3, 4, 5 questions, and you would have seen that the differential of e to the x is e to the x. All right, so let's go now. There's something that is missing. Sorry, especially in the first 3. Sir, we're seeing the e to the x, e to the 1x here. We're seeing e to the 2x up here, sir, right in here, sir. Sir, we're seeing e to the 3x here, sir, right in here, sir. But, sir, I don't know where this 1 and this 2 and this 3 comes from. Thank you for asking. You see this 1x up here, sir? I am differentiating.
Differentiating the 1.
Oh, exactly.
Thank you, Shani.
We are talking about, sir.
Sir, we actually know that.
Sir, I mean, look from the look on it. I see I differentiate.
Bright students, yeah, man. Pop, pop, pop. Who say we can graduate because we pass calculus 2?
All right,
That's just lied.
So we're brighter now. So we're brighter now. So when we
pass, differentiate x squared for me. Differentiate x squared for me. You're brighter now. Differentiate x squared for me. How you get?
2x.
X.
See it right here, so? It right here, so. So you differentiate the function and then write out the function. You see that?
Yeah.
Watch this now. Differentiate from it 3x squared plus 5x minus 7. Tell me what you get.
6x plus 5.
6.
Magic. And then you write about the function down.
Yeah.
All right. Watch this now.
Watching now. I'm going to try and mash up on
so we can clearly see that we differentiate the differentiate the function and write back the given exponential, the exponential function. And so something we can clearly see that the answers or the answer ANSWER is the differentiated function. No, is a differentiated function or the differentiated power COMBIN combined with the given exponential function. Tell me if that makes sense.
Combined with, yeah, man, that makes sense, sir.
It makes sense to everybody else?
Yeah. Combined with x.
Yeah. So we can clearly see that the answer is a differentiated power. So we differentiate the power and then we combine it with a given exponential function. All right. So this y equals e raised to the 3x squared plus 5x minus 7 is really the differentiation of this up here, so which is going to be 6x plus 5 times all of this. So it is the differentiated power combined or times the given, let me put times, T-I-M-E-S, times the given exponential function. And that's what or differentiation of exponential functions is. Right? That's all that it is. There's nothing more. But guess what? There is a trick. There is a trick because the exponential function could be a chain, it could be a product, it could be a quotient. It could be a chain, it could be a product, it could be a quotient. No. So therefore, the exercise that Sir did last week in terms of recalling the differentiation using the power rule, the chain rule, the quotient rule, the product rule is something that is very important in order for us to do even something like this. Very important. Oh, what? Watch me. Blow. Sir, I'm done. Because the first five.
I'm done.
See, that's
Sir,
all.
I'm done.
Them thing never talk about, man.
Yeah, man. Circumference of the moon when you give me a tennis
Yeah,
ball
you're
to
right.
work
Look
with.
at that.
Hey, I was once a student, you know. So, I was once a student, you know. So I know how my students think, and I'm when I teach, I think like a student. All right. So watch me, sir. We know that the answer will have e to the x squared plus 5 over x plus 5. See it? E to the x squared over x plus 5. Yes, sir. We know that this is going to contain the answer because the differential of e to the x is e to the x. So we know that this original question I got in this. But the part that I don't know, sir, is the differentiated power. So there are two components. There are two components to my question. Component number one is the exponential function itself. And component number two is the differentiated power. So I could write down this piece of the answer. I know say that piece of the answer the same piece of the answer so. But I know I have to differentiate this. This is a problem. But sir, what is this again? Oh, sir, it's a function, it's a fraction. So it is the quotient rule, sir. Very good. Let's go. The product rule says, the quotient rule says, the denominator times the differentiation of the numerator.
Sir, that's something that sir.
Minus the numerator, you better learn it. Minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Sir, go again. No problem. The denominator.
Yes, sir, we are going to know what to use the
quotient rule.
The quotient. Yes.
When it is that you see the quotient.
All right, it's going to say.
Yeah. Tell me what the quotient, please.
The quotient is when you have a fraction, a numerator and a denominator.
Oh, write that quick, sir. Write that, please. Once you see the quotient or whatever, whichever big red, you want to use it to mess with the subtle minds of our students. Can't believe someone never remember what the quotient is. Jesus.
Watch me. So what I'm saying to you is, we now need to differentiate. We now need to let y be equal to x squared over x plus 5. That's what I'm saying to you. You need to let y be equal to x squared over x plus 5. All right. So dy by dx is going to be equal to the denominator, x plus 5, times the differentiation of the numerator. When I differentiate the numerator, x squared, what do I get?
2x.
Minus the numerator, which is x squared, times the differentiation of the denominator. When I differentiate the denominator, what do I get?
1.
1.
Very good. All over the denominator squares, which is x plus 5 all squares. Remember, when we're doing the quotient rule and we get our x plus 5 all squares, do not expand it. I think Kimani asked that question last class. Yeah, I think Kimani asked that question.
You don't touch the denominator.
We don't square the denominator. Somebody asked that question last class.
All right, sir. Hold on. Go back to the top part.
The first times the denominator.
Yeah, which is that.
Which is this. Yeah. Times the differentiation of the numerator.
Which is x2, x
squared. Good. Yeah. Minus the numerator.
Yeah, which is x squared again.
Times the differentiation of the denominator. When you differentiate the denominator, the differential of x is 1, and the differential of 5 is 0, constant, not. Right? So it's the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. So I'm just going to fix up this piece now. So dy by dx is going to be equals to 2x times x is 2x squared, and 2x times 5x is going to be 10x, and this here is contained in a parenthesis here, x squared times 1 is x squared, so this is going to be minus x squared, and this is all over x plus 5 all squares. dy by dx, you'll recognize when I group those two together because they are the same. One is
positive and one is a negative, so that means it have a drop down.
No,
so
x squared.
So that's going to be a drop down to x squared. Very good. So we have x squared plus 10.
Plus 10x.
No, 10x, yeah. X squared plus 10x over x plus 5 all squared. Watch what happens here. Because the x's are common, I can take out the x and say x times x plus 10. Talk truth.
Yeah. Yes, sir.
Yes, sir.
Sir, what happened to that step there, sir?
You want presentation.
Sir, are you saying that if I don't do that last step, I'm not going to get full marks?
It depends on the day. It depends on what the question asks. No, seriously. No, seriously. It depends on the day. No, it depends on what the question asks. The question may say to you.
Sir, so based on my past classes with you, that means, say, if you don't get your shoe piece with oxtail by Sunday, and you get up off and left your yard and go do something, that mark. See? And you fix your mark paper with salt. And that's your choice.
No, I'm just saying to you, the question may say, no, the point I'm making, is that the question may say, simplifying your answer. You see what I'm saying? So it depends on how the question is asked on that given day. So, and it also depends on what mark scheme you're getting. So I always say to students, whenever you're doing anything in mathematics, go down to its lowest term. Always, and incidentally, sometimes when you factor out, sometimes the numerator comes out with an x plus 5 in there, where it is that it can cancel. So you always break down to its lowest term. So in a case like this, because nothing else can cancel, you wouldn't necessarily lose any mark. That's the point I'm making.
All
but
right, sir, I get you, sir. But look at this. So you say you have this square there, so right? So you take out the 2x and you factorize. Take out the 2x, you put back the x and put back the 10, right? Cool.
Over the x plus 5 all squared.
Yeah, over the x plus 5. What is this? What you have? What is something I saw again? What is this?
That was the original. That was the original thing. You remember, so the differential of e to the x is e to the x.
Oh, yeah. My bad.
Just eat it up back with it. Now look at what I just wrote on screen versus what I typed for you recently, and tell me for the same something.
No, what you type harder.
Same thing, sir, just the opposite side.
And I deliberately put it like that. At the same something, you can't go wrong. No, hear me out. Remember, you know.
Sir, don't worry about, don't clear that, you know. Left that on the document, you know.
Yeah, man, I'm not being clear. The differential of e to the x is e to the x. The differential of e to the x is e to the x. And I can't overemphasize that. The differential of e to the x is e to the x. Please remember, the differential of e to the x is e to the x. Now, if you get a function that is a chain, like the ones I did up top, like the ones I did here. No, man, all right. Because these are just applying the chain rule, you know, because this is just a chain rule. You just differentiate individual terms. The differential here, so of 3x squared is just 3x. 6x.
Sir, point out the differences, please. Why you would use a chain rule different from the quotient is with a fraction, right?
Very good, very good.
And the chain rule is what we use with everything else, correct?
No, the quotient is with a fraction. The chain rule is what is contained with plus signs and minus signs, like this one here, 3x squared plus 5x minus 7.
That makes a chain.
The product rule is when you clearly have brackets or multiplication and something. So product means to multiply. So whenever you see brackets in the stuff, it means that is a product rule. And I have questions like that to give you just now. When you have only plus sign and minus sign, 2 plus x minus 5 plus this plus that, you know, that is chain rule.
Yeah.
Right. So so the chain rule is separated by addition signs and subtraction signs only. So remember, you know, look at it this way. I'm not writing this, it's just point of information. Look at it this way. There are 4 basic operations in mathematics. 4 basic operations in mathematics: addition, subtraction, multiplication, and division. Addition, subtraction, multiplication, and division. Let us talk about the division. Clearly, the division stands alone. Quotient rule. So once it is that you have something divided by something, meaning a numerator and a denominator, quotient, right? So what we have is the 4 basic operations are addition, subtraction, multiplication, division. The last one in that, division, is going to be quotient. The second to last one in that is going to be the multiplication. Multiplication product. So using the product rule. The first 2, addition and subtraction, will be the chain. Addition and subtraction.
All right. Slow down. Start over and don't do it. Say it like you just drink 6 cups of coffee.
So the 4 basic operations are addition, subtraction, multiplication, and division.
Cool.
And I'm saying to you, when we're talking about addition and subtraction, we are as it relates to differentiation, we are referring to the addition and subtraction.
Okay.
When we speak about multiplication, we're speaking about the product rule.
Okay.
When we speak about division, we're speaking about the quotient rule. So the quotient rule and the product rule stands alone, and the chain rule is a combination between the additions and subtractions. So in all these cases, they are the chain rule. But sir, x squared is the chain rule? Yeah, because it stands alone. Stands alone, right? So remember, it's going to be the differentiated power times the exponential function. So I have to differentiate the power. So I just differentiated the power right here. So just differentiated the power times the exponential, the given exponential function.
Oh, and you have to put that back, and that's the answer.
Yes, sir.
All right, scroll up.
So do me a favor.
See, you know, I see the question I really want you. Oh, okay.
All right. Hold on, please.
I'm right, that already, you know, sir. Because edit, sir. So this is gonna be the chain rule then. So we're supposed to do this now? All right, for wait.
No, man. I'm coming to show you something. I want to do this one with you. All right. I want to do this one with you. Let me just. Come. All right. I want to do this one with you. And again, so I did one with the chain. The ones in the box contain all chain.
Hold on.
I did a quotient, and now this one is a product. Can you see that? Can you see that this one is a product because something is multiplied by something?
Sir, I think this was going to be a chain.
No, man, it's a product. You see brackets in there?
Oh, yeah.
All right. When you see brackets in there, it's multiplication.
Product. Right,
all right.
Okay.
So look at what I'm gonna do. I'm gonna change this and call this something. Hold on.
So I'm gonna get times 7 plus.
All right, watch me now. I just changed something here. Remember the product rule says the first times the differentiation of the second plus the second times the differentiation of the first.
So if you can't differentiate which rule you use your salt, you're dead in the water.
Salt like brine. Let me just see if I can find. I kind of feel lazy. I don't want to retype all of that. Jesus, Father. I don't want to retype all of that. Copy.
So you have your class manual down, you know.
Straight up. Nobody can pay a teacher. Nobody can say Mr. Shan come class and never teach, you know. Negative. And every time I go through this stuff, more stuff is added to it. Rockstone. I'm at 32 pages now. Whoa.
For the whole course?
No, man. The whole course is about 100 and something pages.
Jesus Christ.
No, don't worry about it. It's just that the solutions to the examples, you know, takes a lot of working out. So that's why. So like all this question now, we take a couple of pages something. Like all I put in this right here, so now. So I don't need to recall. Okay, let's go ahead. All right, so the rule says the first times the differential of the second plus the second times the differential of the first. Sir, why did you go ahead and recopy that stuff? Because I just changed a question a while ago. I mean, just amended the question and put in what represents my first and what represents my second. Let me also.
So the denominator will be 1.
There is no denominator in this one because you don't have a fraction. No. And that's why you use to differentiate it. What is wrong here now? All right, guys, my system not responding. Hold on. All right, let me just save this. All right, hold on, guys. System is slowing up. Okay. All right. So you see what I did put in pink is what I'm calling my first, and is what I'm calling my second. Is what I'm calling my first versus what I'm calling my second. So it says the first times the differential of the second plus the second times the differential of the first. All right. Now, in this, my differential is the first. See me right back the first right here, so? Me right back the first right here, so? Sir, what the first? Oh, the first is 2x minus 4. See it right here, so? 2x minus 4. The first times. See times here, so? Times this to this to that. The differential of the second. It means that I need to differentiate the second. In differentiating the second, I know I'm going to differentiate up here. Remember, when I told you to differentiate an exponential function, it's going to be the differential of the power times the given function. So I'm going to differentiate 7x plus 1. When I differentiate 7x plus 1, I'm going to get
7x.
7, not x, 7. See here?
7.
That's 7 here. So, and see the function here, see the original function here. Same thing, e to the 7x plus 1. See this up? E to the 7x plus 1. So I write back this, e to the 7x plus 1. So the differential of e to the x is e to the x times the differential of the power. So the differential of e to the x is e to the x. See here? E to the 7x plus 1, e to the 7x plus 1. Then I have to differentiate the power. And when I differentiate the power, I get 7x plus 1. All right. Based on the response just now, I didn't like it at all, to be honest. So let me go back up here. So we can clearly see that the answer is the differentiated power times the given exponential function. The differentiated power times the given exponential function. See here? It is the differentiated power, which is 7, times the given exponential question, which is up here. So, all right. So this is now the first, which is this, times is this, the differential of the second, which is all of this, plus, see it right here, so the second, me right back with the second base. See the second here, so e to the 7x plus 1, e to the 7x plus 1, times is this, the differential of the first, and the differential of the first is going to be 2, right here, so you see what I have in blue is differentiation done. You see everything else in black is the little algebra to put it together, and what is in red is the answer.
All right, sir. Hold on. All right. This is for soak in a little bit, sir.
No problem. One thing first, though, guys. One thing first. It can't take it too long for you to soak in, because I did say to you, come 11 o'clock, the last hour of the class, I'm going to spend time with my current series on that. So I'm dedicating just an hour for the exponential function, right? So I'm saying this to say to those of you who would want to come alive in 15 minutes time from now, that you don't have that time. Come alive now. Go ahead, Everton.
No, I'm just looking back at the explanation and try and penciling it out. So in the future, if we get a function, right? Once we have the brackets here separating it, we are going to use the product rule, right? And once we use the product rule, anything in the bracket is going to be the first, anything out is going to be the second, correct? All right, cool, fine. Then you're going to differentiate the first and the second, and then multiply them back by their coefficients.
Hold on, don't do it like that. Don't do it like that. What I would suggest to you is just like what Sir did, write what the first is and write what the second is. And incidentally, when I learned this stuff when I was in high school, I always had my pencil with me, when I had things. So I write the question in a pen. In a pencil, I write down which one I call first and which one I call second. And I say every time I do the question, I know the story. The story says the first times the differential of the second plus the second times the differential of the first. And as I'm writing, as I'm doing the question, I'm looking at it. The first, write down what the first is. See yourself? Times, we put the multiplication sign. The differential of the second, it means I'm going to differentiate the second. But I remember in differentiating the exponential function like this, it's going to be the exponential function itself times the differentiated power. So it's going to be the differential of 7x is 7 times 7. So all of this is the differential of the second.
Sir, so what if you put this
the 7 in front of this?
Front, yes, sir.
No problem, Shani. Same difference.
Okay.
Tomato, tomato. Same difference.
All right.
All right.
Because that's what I would have done.
And no problem, honey bun cheese. And then this plus is right here, so plus.
And then you differentiate that.
No, again, right back the second.
And then you differentiate.
And then I differentiate the first.
Oh, you just tell me someone could have put differentiate first and put that at the first.
No, man. No, but let me tell you what I want you to do. I want you to follow this rule as it is, because that is the story that you are going to remember it. The first times the differential of the second plus the second times the differential of the first. You know what?
Nice.
I'm gonna erase something here and then
why?
Because I want to put the rule right here when I'm doing the stuff so you can see what the rule looks like. If you like what I did it right here, I should have done it right here. The denominator times the differentiation of the numerator,
sir,
minus the numerator.
Press enter, sir, and then
I can do that. I can do that. I can do that.
So I'm not gonna lie. I think the way you structure this is good. You revise, when you come in, you revise the last class. So
Yeah,
it is, so you kind of get my brain start work. So by the last 2 hours of the class, that is when I'm ready to accept new information because the brain wake up.
absolutely. And that's how I do my thing. Remember, at least I teach like a student.
Again, that's I'm so why sir what you train. First time.
Remember, we're not on speaking terms, right, Romain? You cut out 2 hours out of a class in the
Sir,
Romain.
let me ask you something,
Sir, I just put it alone, sir. Sorry,
let
sir.
me,
Just
sir,
put it
I'm
alone.
gonna ask you a very valid question, sir.
Yeah.
Right? Why doesn't Excel allow students, right, if you have 2 classes, correct? To select the class that they want to be in?
Because some teachers will have all the students and other teachers will not have any study. So I will not. I'll be the first one to run that down when they bring that rule in place. I will tell them nope. I will tell them no. Or
sir,
if
you
them have
can't run from the work, you know, sir.
Master, sir.
Sir, hold on. With great strength comes great responsibility, you know, sir.
And I'm going to tell you something. There is somebody in the class here, and I'm not going to call the person's name, and I want the person not to identify the person's self. It could be a male, it could be a female. The person called me in while they were doing calculus 2 to say, "Roop, sir." I said, "Don't worry about it. You're fine." And when the result came and the person says to me, "You see?" He said, "Oh, long me, I beg you." He said, "You teach and support and so on." I said, "Don't worry about it. There are 1 or 2 of my students too who did fail. So don't worry about it." The truth of the matter though is I find it to be very dangerous because students have their preference. And guess what? Some students will say, "I am not selecting Mr. Shan's class and I'm going to select another teacher's class," because students have their own preference.
Good. So let us prefer.
But no, let us randomly place students in class so everybody gets an equal
sir,
opportunity.
but everybody learn different and every teacher teach different, sir. Teacher.
Yeah, man, because some people teaching style is like them say.
Different, yeah.
They're supposed to know this.
Yeah.
That are the question.
Yeah.
What
But as I said before, I know what it is like, and I know, there are 1 or 2 of my teachers that I want to see now and just look at them and just smile because,
sir,
with
my experiences, let me tell you this.
Don't call my name.
See, I have done classes with multiple teachers from your department. And only 2 teachers that I've had passes with.
And only because that one is a very sexy one, that's why.
Listen, that is why I failed the first one. That is why I failed. I failed that one.
Okay.
It's Mr. Bacchus and you. I'm not pass no other math course with no other teacher.
Well, guess what?
You're Bacchus the general man.
Sir Bacchus, when Sir Bacchus look at you, the man say, him call you out in front of it. Like how you call you out. Him call you out, man, and say, listen. When I was young, I see people working at garbage truck. I say,
well, trust me, if me can get a garbage truck worker for him, I take it. Because then people, them get about $30 an hour a year.
Well, I'm not talking about garbage truck or foreign. I'm talking about Jamaica. It's the amount of work.
Sir, that's not the title over here, sir. The official title over here is
sanitation expert?
No.
Sanitation
engineer.
Disposal technician.
Well, guess what? Okay, waste disposal technician. Just like you're a flight attendant, you're a helper. So I'm saying to you, Orlando, give me a sanitation expert, job, right? Because guess what? No, the truth is, at $30 an hour, it is cheaper. I mean, it is more lucrative for me to become a sanitation hygiene expert, whatever the situation is, than to go and flip.
You can work out 2 jobs, sir.
I mean, if you tell you, than to go and flip burgers.
No, sir. Sir, senior nurse, I get $15 hour.
I will be a sanitation expert. And guess what? And them clean. When they say them clean, because remember, they don't. It's not like our garbage truck people were interface with the rubbish, Them in a uniform and them have machine taking up the garbage, so you don't even interface with. And guess what? even if you have to interface with the garbage, by law, it's like how we use candle bag and just throw the garbage in. If the garbage don't look presentable, they are driving past it. So
it needs to be separated.
Absolutely.
Anything can.
Guess what? And guess what? You see, when you go foreign and me turn one of those sanitation experts, and me come to your yard and pick it up, don't call to me and say, geez, I'm to teach you maths. Go on like you don't know me. Straight up. Because when I apply for the job, I'm not going to tell them that I was a math teacher. Because
you're not going to tell them say you have a PhD neither.
So I am saying to you that me is just one little man who barely can read and write getting 30 up, because when you come to my yard, remember say it's 3 stories begin living to with one big swimming pool.
And the X15.
And the X25. Let's go. Let's continue. Look, so it's the first times the differential of the second plus the second times the differential of the first. Now watch me. Again, I'm doing this for the last time before I go into this black area here. I color code it because I know I can use my spotlight, but I've
30 seconds. Don't.
All right, no problem. But guys, while he comes back, I just want to say to you again, I really, really, really want you to pay attention. I try my very best in presenting the information so it is that you can see what is happening. I was just about to say that I color code the stuff so you can see the different segments of the calculation, right? So what is in blue is the differentiation. What is in blue is the differentiation. Now, what is in black is just algebra. It's just how I put in the things together to present it. And then the final analysis of it, what is in red, is my final answer. All right? You back, Everton?
Yes,
right, so let's go. Let's go now. So it is the first, which is this. Times is this. The differential of the second. The differential of the second is this and this. Now, Shanice says, sir, I put the 7 in front of it first because when you just said something, sir, you just say it is a differentiated power times the exponential function. I know I said that. It's not a problem, yes, because it is what it is. So this is that. Plus, the big plus sign here is this. The second, which is, see the second up here, so, which is this, times the differentiation of the first. And the differential of the first, so the first here, so when I differentiate the first, I get 2. This is this. My differentiation ends right here. You pick up quite a number of the marks right here. Very few marks is given for here and here. So if this is a 7 marker, if you present this to me here, you get about 4 marks out of the 7. All right? And then here, so now is where you pick up the other 3 marks. And I'm being very honest and frank with you. Very honest and frank. All right? So now, look at what happens here. Now, you see, because all of these here, so, are being multiplied. See here? All of these here, so, are being multiplied.
You put the 7 out of the
end. I put the 7 out of the end, and I write back this, and I write back that. And then this plus right here, so I just put the 2 in front of that. So, Shanice, that's why I said to you, say you can put the 7 anywhere. Same difference. So, all I'm doing, remember, you know, multiplication. This multiplied by this, multiplied by this. So, BOMDA says, brackets of multiplication and division before addition and subtraction. So I have to do the multiplication part first before I do the addition part. Just remember, BOMDAS, it follows through from little school maths to big school maths. All right, watch me. So I am doing all of this piece right here, so, and I'm just rearranging it here. So by putting the whole number 7 in front of, and then I just write all of this here. So then I put back the plus sign, and then I just carry the 2 right in front of here, so, and times it by this right here, so. So I'm getting nicer. Oh, but hold on, sir. This exponential function is the same as this exponential function inside here. So we can factor it out. Factor it out right here. So, okay, sir, let me see that. So what is left? If we take out this and this, what is left is going to be 7 times 2x minus 4. You see it?
Yeah.
7 times 2x minus 4.
Plus 2.
And if we take away the 1 here, I got the plus 2. Very good. And then now, again, BOMDA says brackets of multiplication and division before addition and subtraction. I have to work the brackets first. So 7 times 2x is 14x, and 7 times negative 4 is negative 28. And then now, we can just work up that piece here. The 14x is by itself, we put it back. Negative 28 plus 2 is negative 26. And then I just grab at this at the same thing as this, at the same thing as this. And sir, I'm done. Finish.
Wow.
Finish.
Wow.
All right.
Part of the hard part.
So do me a favor now.
Sorry, go right again.
Go back again. All right. So what it is that I have done, Peter, is just to say,
I
the first,
understand how I get the DY DX, the blue part.
oh, you understand that? Okay. So let me start from the black then. So I have to do my multiplication before my addition. So this 7 is going to be multiplied by all of this. I'm going to multiply all of this first part here. Starting from my positive sign, I can't do this part with this part because multiplication first before addition. So I'm multiplying all of this, 7 times all of this times all of that. See here? 7 times all of this times all of that. So technically, all I'm doing is putting the 7 in front because see, this is in the same position, and in the same position, but just putting the 7 in front of it to make it look nicer, right? Start off small and then we get big.
Yeah.
Similar here, I just put this 2 in front of here, so I'm just be like that. All right? And then now, when I reach this line, I'm looking to see what is common. Now, in that line, I recognize 2 things are common. The e to the 7x plus 1 in this part of it, and e to the 7x plus 1 in the other part. Remember, the plus sign separates these 2 components. So you see here, the first times the differential of the second. That's the first part of it. The plus sign, that's why I put it in big, in bold, in upper caps, because this piece separates the other part of it, the second times the differential of the first. So now, when I factor out this x, e to the 7x plus 1, I'm going to be left with, see, when I factor out that, I'm going to have just 7 times 2x left. And when I factor out this, I'm just going to have 2 left. And then inside of the parentheses now, I'm going to have 7 times 2x is 14x, and 7 times negative 4 is going to be negative 28. So I'm going to have negative 28, and then my plus 2. So what I'm going to have now is the negative 14, sorry, the positive 14x is a standalone. That's the only term that contains an x. So I'm just going to put it back, 14x. And then I'm going to have negative 28 plus 2, which is going to be equal to negative 26. So I'm just going to put my negative 26, and that gives me my final answer. That gives me my final answer. Final answer.
Okay, sir.
All right. So do me a favor now. I want to keep that projected, and as I wrap up this area, it's down 3 minutes to 11. As I wrap up this part, I'm going to give you one to do for me. I'm not even going to type it because I can type it, but I want to keep this piece projected.
Yeah.
So that you can follow what is happening here.
All right, I'll type it in the chat then, sir.
No man, I'm going to do it right here. I'm going to do it right here.
Oh, okay.
Y equals say 3x squared times e to the x plus 1. I'm going to get easy. Find dy by dx. And that's a do now. I'm going to give you 5 minutes. I'm not going over to the 11 o'clock, but I'm going to give you 5 minutes. I'm going to use this 5 minutes to kind of refresh myself and then come back to you. So I'm going to mute for a moment. All right? Start working for me, please.
All right.
Cool.
I got a differential of exponential function.
First time the differential. Second one. First.
Yo, I want to get, brother. Yo, people, anybody want to get?
Me get EX plus 1, non-X bracket, me get 3X squared plus 6X, so that me have.
That me.
That me get too.
Oh God, me no work
Can't
this.
be answer.
Me no work
Never be an
this.
idiot.
Me no work this. Brother, me I say, but this can't go
Never
down
be
no
an idiot
further.
today.
This
Can't be
can't go
answer.
down no further. Why? I say, well, we can factorize the second bracket. No, that not
No,
gonna work.
sir,
Make that
me
stay.
factor out like that.
That stay. Make that stay. All right. I'm there. You know,
Sir,
long me
come
there.
back, sir. I don't look like idiot, man.
You know much mark up the paper.
A pencil I use. I will be a rubber about.
Yeah. I swear. That in the lie. Me recommend him. Recommend. You know more do more find out. Be like that. Wow. Him say man make it easy. And come back. We're dead now.
We finished?
I tell you, see that, sir. I live long enough.
Yes.
All right.
Sir, yeah, we finished, sir, but we know you're kill me with the answer.
Sir, we need not go tell you what answer, sir. Do what you do.
No, I want you to answer first.
Sir, we get EX plus 1 bracket 3X squared plus 6X.
3X squared plus 6X?
Yeah.
Yeah. Dy dx equal to the way I'm just say about that.
Yeah.
Yeah.
All right.
Crucify we know, sir.
It's not necessarily just that based on what you just said to me a while ago, I see where I could.
Sir, you know,
like some more could I do to it?
Right. I see where I could do. I could fit more to it.
Sir, wish pass, sir. Come and look upon it all long and mark up the paper here and I say that can't work, and that can't work. So,
all right, I'm gonna show you. I'm just being lazy here. So well, I'm just trying to be working smart and not hard.
Oh, hold on. Sir.
No, I don't read it in. I'm just copying.
No, hold on. I am saying something, right? Based on that, I could have said 2, no, but then I factorize, would have factorized the second bracket again. I would have take out the 3 minus 3, that got 2 times. So 3 that. So the second bracket that read x squared. Yeah, and no, but that then that.
When I go be minus and when I go be plus, it'll be like a perfect.
Yeah. That after that because you have the square.
Yeah.
But me now go, sir can't tell us that what to do to, sir.
Well, actually, something like what you just said a while ago, I would say that we need to do. All right, just check to see if this is the correct question. 3x squared times e to the x plus 1.
Yes, sir, that's a question, man.
All right, let's go. So it's a first.
Yeah.
It's a first, which is going to be 3x squared. The first times the differentiation of the second. When I differentiate the second, what do I get?
1.
1.
Times. Remember, you have to put in the x plus 1, you know.
Yeah, man. Times. Yeah.
X plus 1.
Good.
Plus px plus 1 times the differential of the first.
What's the differential of the first?
6x.
Good job. Good job. Good job. So I'm now gonna have 3x squared. I'm gonna have 3x squared times e to the x plus 1 plus 6x times e to the x plus 1.
Yeah.
You can say that's what you have.
Yeah, man, I have that, sir. But I kind of shuffle it around, man.
No
move
problem.
the thing them come out of far. Yeah. All right.
No
Cool.
problem. Not a problem. And
Next
then
one.
now,
The
the other
factorize.
piece now, I'm gonna say what is common is gonna be e to the x plus 1.
Yeah.
And no, that's not what is common, you know. What is common is gonna be 3x. Because remember, 3x can go into 3x squared and 6x. Talk
Yeah,
to.
that, sir, so that me I say a while ago.
I
Sir,
know.
hold on. Sir, when we do it that way, yeah. Sir, so what I was saying, if we can do the two of the, if we remove the ex first, then we can go back again and remove the 3x after again. So you'd end up with ex. You'd end up with ex plus 1, and then you'd end up with x. Oh, no, but yeah. Sir, oh God.
All right. So what I'm saying to you is that your answer that you gave me 3x squared plus 6x, right?
Yeah.
That's what you gave me for the answer.
Yeah.
All of you?
Yeah.
Sir.
Yeah. So all I'm saying to you is that you can finish factorizing it and just give me the final thing as 3 open bracket.
Oh, okay. So 3 open bracket x. No, squared 3. Okay. So 3.
All you need to do is just factorize
3x
it.
squared plus
3x times x plus 2.
Plus 2. Yeah.
Yeah.
So
hold on. 3x what?
3x times x plus 2.
Yes.
Because what you would have gotten, what you gave me, what I heard for your answer is 6x squared, is 3x squared plus 6x. That's what you said, right? 3x squared plus 6x?
Yeah. Correct. You're correct.
So just factorize that, yeah. And so guess what? Guys, that's very good. That is
3x.
excellent. That is excellent.
When you sit down now, just like the last time before my pass, I have to factorize the 2 days straight before I could have passed the test.
That's excellent.
Sorry, so if you put e to the x plus 1 in front of the 3x, that good? I mean, if I put now a separate bracket.
You have to bracket it, man. You have to separate it. You have to separate it.
Bracket it and separate it?
Yeah, man. Yeah.
I mean, it's a shiny deal, you know.
Yeah,
and if you not write it pretty too, and if you not write it pretty too, take off marks.
Yeah, man.
Realize.
Violate the general.
You can't violate at all, trust me. All right, very good, guys. All right, excellent. Now, as Everton said before, yes, you will see this again. When we're doing our review come next week, Saturday, all being well. But I'm going to see, this week I'm hoping to be a little lighter. I have one set of papers to mark out, and I'm really hoping that I can use between today and tomorrow to mark it off. So come next week, I should be, providing that we don't have the meetings we had last week, I should be a little bit more free, so I can send a little 1 question or a little 2 question, so they can get that to practice, whatever. So we have 45 minutes left, and I'm going to go through Maclaurin's theorem, right?
So when you send a document, sir?
I can send it today. You see, I'm working. That's why I'm working. I decided not to write today. So that I can go through the document, and I'm updating the document as I go through. So I can send the document. It's just that I'm not sending the whole piece because I don't want people to write. So I'm just going to extract what it is that I would have used, right?
Yeah.
Okay. So we're looking at Maclaurin's. Remember I told you that it was spelled incorrectly. So we're looking at Maclaurin's theorem for approximating functions with indefinite series. Now, work with me. Work with me. So we've gone through, the first thing we did last class was to do a review of our differentiation, chain rule, power rule, product rule, and quotient rule. Then we moved straight into Newton-Raphson.
Okay. So
That took us up. For this week,
this is gonna be the quotient, right?
no, man, no, we're not going to use the quotient here. Well, it depends. It depends on the function given. So this week, what we did was to do a review of what we did last week, and then we went into some more to just kind of juice it up, the Newton-Raphson method. Now we finish off the Newton-Raphson method. So Newton-Raphson put up in our bag. But what I'll try and do is to put a little one question here and there, so it is that we can remember the steps for Newton-Raphson. You remember that I would have sat in class today and wrote a summary of the Newton-Raphson, so it is that we'll know what to do every time we're doing this stuff. Huh? Now, there's another review that I need to do, but no, I'm not going to do that review just yet. So what we moved into next was the differential of the exponential functions. And then we look at some examples of the exponential functions, and again did some review of the product, the quotient, and the chain rules. Right? Now it is that we're going to be moving into some Maclaurin's theorem. And the Maclaurin's theorem now is going to also involve using the same product, quotient, or chain. We don't know which function them going to give. So we can't decide, say, boy, sir, we can only differentiate using the chain rule. We have to know the other rules, because the man may be mischievous and give us an exponential function to do, or the man can be mischievous to give us a quotient or a product or we don't know what. So we have to be versed in what it is that we're doing. All right. But before I can move into the exponential function, let us look at our at our formula. It says f of x is going to be equal to f of 0 plus f dash of x, Rockstone, sir. I think we made f dash of x. F dash of x was the first derivative down, sir. Absolutely. And then we talk about f double dash. Sir, that means that is the second derivative. Very good. And then, sir, the third one is going to be the third derivative, and so forth and so on. And then the f to the n is the nth derivative. Sir, I see. No. Sir, but hold on. When you talk about the nth derivative, sir, does it mean that it can go up to 5, 6, 7, 8, 9 differential? Very good. So I don't know how far the question is going to ask you to go, but anything the question asks you to do, just do it. There are one or two things that I need to point out in the formula that will make this calculation seamless. Work with me. F of 0 okay, all right, no problem. So look at what is going to happen. F of 0 stands alone. F dash of x. Do me a favor. Take out your. No, don't read it. Don't read it. Don't read it. I am going to do something because I really want you guys to get it. So I'm going to do something. I'm going to do something here. I'm going to reach right here. You're going to reach right here, sir? Yeah, I'm going to reach right here. So I'm going to do something. And then paste that here. I'm going to soon come. All right, let's go. All right. Okay, so it's f of 0, it stands alone. F dash of x, f dash of 0 of x stands alone. F double dash of 0 over 2x squared. F double triple dash of 0 x cubed over 3 factorial. F to the n of 0 x to the n factorial. Wow. There are 3 things that I want you guys to see if you see. What 3 things you see?
The derivative is always followed by the second factorial, the corresponding factorial.
And that's just p's.
And it's and it is multiplied by
it's going to be x to the same power.
Yeah, x to the same power, but x is going to be f of x, f of 0, right?
Yeah, man. No, man. Don't worry about the f of 0. Don't worry about the f of 0 part yet. So very good though. So the f double dash it means that it's going to be over 2 factorial. So I can't have f double dash over 3 factorial because this 2 up here, so the double dash is 2 factorial and it has to be x squared. So I can't have f double dash 3 factorial for x to the 4th. This 2 corresponds with this 2 corresponds with this 2.
Okay.
This 3 corresponds with this 3 corresponds with this
Yeah.
3. This n corresponds with this n corresponds with this n. Is what I'm saying?
Yeah, and that means and so on. That means
And it's not that means and so on. All right. Let me just show you something here. Copy. I pasted somewhere there. I want you to take note here. I'm going to show you something. What's not hard, you know? If you follow the principles, you can see.
Sir, if you follow a principle and you still feel, sir, you gotta give up, sir.
No man, you can't give up. You can't give up. Yes, hello, Virgin.
Me I gotta say that now when me at the end of the course, see?
No, I'm if I tell you, and guess what? And we can't give up, you know, because we don't fail. Jamaicans, when you watch this now, you see what Sir never did that before? If you follow the sequence, see this is 1, this is x to the first, 1 factorial, don't it?
Yeah.
How much not written up, yes or no? That's a 0 down. But x to the 0, matter of fact, I should put that here.
Is itself.
Anything raised to the power 0 is?
Itself.
The 1.
1, yeah, 1. I forgot a beach or something to relax myself.
Oh man, maybe you see the man, trust me.
Feel like that got big boss.
All right, watch me now. See, x to the 0 factorial,
yeah.
And that's a 0 here, so. Yeah. F to the first, see, 1, 1, 1, 2, 2, 2, 3, 3, 3, so forth and so on. All right, so that's what that is. And somebody may say, but sir, you did say that we can't divide by 0. True, but this is not 0. That's 0 factorial. So, sir, what is 0 factorial? Thanks for asking. Let us review the factorial notation. So, n factorial is simply saying n times n minus 1 times n minus 2 all the way down until I reach k, the last number. All the way down until I reach k, the last number. So, example, if I say to you, evaluate if I say to you evaluate 5 factorial. Let's say to evaluate 5 factorial, right? If I ask you to evaluate 5 factorial, the solution here is going to be
all the way up to 5.
All the way up to until I reach 0. From 5 until I reach 0. Copy.
Oh, hold on. From 5 till I reach 0. Is the other way around?
Is the other way around, yeah. So I'm going to start from, so I'm going to have 5 times 4 times 3 times 2 times 1. We're going all the way down to the last term. So watch me now. So 5 factorial is 5 times 4 times 3 times 2 times 1, right? So see here, 5 factorial is going to be n. So, sorry, n factorial is n. So anything you have to find a factorial of, you have to multiply by it. See here, n is n factorial. So this n is the same n here. See here?
Yeah.
Oh, crap. Sorry, I left out something. So look at that. So 5 factorial, see I multiply by 5?
Yeah.
Then this is going to be n minus 1. 5 minus 1 is 4. 5 minus 2 is 3. 5 minus 3 is 2. 5 minus 4 is 1. So I can go down to 5 times 4 times 3 times 2 times 1. So that's what I do when I evaluate in 5 factorial. And that is going to be 120?
Yeah.
Yes, sir.
Yeah.
So do me a favor now. Look on your calculators for me. Look on your calculators. Look over the x to the minus 1 button. X to the minus 1 button.
Or the x factorial.
Or the x factorial. Very good. and tell me if you, well, once you find it, just put in 5 and just press that button and you should see if your answer is what it's supposed to be. If you get 120.
Yes, sir.
5-second function that equals, yeah, 120.
Very good.
Come on.
And that's exactly what the factorial notation is. You would have been introduced to factorial notation from either discrete math or prob and stats.
Prob and stats, I get it now.
Right.
The boss is a Bacchus.
Yeah, man. So I am just here to just refresh your memory right here, and this one question is to refresh your memory of the factorial. So you know where to find the factorial notation on the on the calculator. So let's go now. So now that you know to find the factorial notation, what is 0 factorial? Evaluate 0 factorial for me, please.
1.
1.
Very good. So this is 0 factorial is not 0. So f of 0 divided by 1 is the same thing as f of 0, don't? Yeah, that's why I never put it divided by 0 factorial. What is 1 factorial?
1.
1. And f dash of 0 divided by 1 is f dash of 0. So that's why I never did that. And of course, x to the first power is just x. So this is why these two first values never had the value down there. Hold on. All right, so that's what that is. So I'll show you here that 0 factorial is equal to 1. Note that zero factorial and 1 factorial equals 1. All right, so 0 factorial and 1 factorial equals 1. So that's what it works out to be. So this is a formula we're going to be using. The top one is a formula we're going to be using, because you may say to me, then sir, if you say math is a study of pattern, we never start from 0, go all the way down there. Yeah, man, you start from 0, go all the way down, you know, because 0 factorial is really 1 and 1 factorial is also 1. So so when we do that now, we now get into our question. And here, see the question here? First question on Maclaren's. It says, expand 1 over x plus 1 up to and including the term x to the 5th. Now let me just break that down for you. Expand 1 over x plus 1 up to and including the term in x to the 5th. Now, it says including the term x to the 5th, it means you have to go to 5 differentiation. We have to go to 5 differentiation. We have to go differentiate the function once, then differentiate the function a second time, a third time, a fourth time, and a 5th time. Sir, why? Because the question says x to the 5th. The question says x to the 5th. So I have to differentiate the function once, differentiate the function twice, thrice, 4 times, and 5 times.
Oh, you spell the Maclaren, sir.
M-A-C-L-A-U-R-I-N.
M-A-C?
It's on the screen.
Okay. These are the correct spelling?
Mm-hmm.
Okay. Okay.
All right. So now, the first thing to do is to do our function. So I'm going to project something and I want you to see what does that mean. All right. So that's a formula. And I said, okay, so I can't take out that because I came to it. I wanted to show you something and I came to it. Now, the first thing to do is to let f of x be equal to the given function. So, you know, look at what the question says. The question said, expand 1 over x plus 1 up to and including the term x to the 5th. The question never named the function, you know. It just give the function. So we now have to let f of x be equal to the function. So we are naming the function. Very important to name the given function. It's very important to name the given function. You have to. Sir, why? Oh, we are going to know what to do. F dash of x and this of dash of that. Remember, so the formula talk about f dash of x and f dash double dash and f triple dash and x to the fourth dash and we have to find f to the fifth dash. So you have to name the function. That's the first thing, right? Now, when I name the function, so therefore we have f of x is equal to that. All right? So we have f of x equals to that. Now I need to find the first derivative. I need to find the first derivative of this. Low,
So now we have
sir.
to use a quotient rule.
Absolutely. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Now, let me just pause and answer questions. I don't know about how others teach, but as I keep saying to my students, I'm a conceptual teacher. Do you now see and understand why I had to take a review last class of the different rules of differentiation? Yeah, because the Maclaren's question and the Newton-Raphson question can come with product and quotient and chain. Them can come with anything,
Yes,
and we
sir.
don't know where them are come with, man. So we have to do this up. And incidentally, we went through another review of the quotient rule and the product rule today, and the chain rule as well. So we have to always be on target. Our differentiation must be up there in order for us to get these questions right. Okay, so let's go. The first derivative. Sir, how you know is the first derivative? F dash of x. So f dash of x tells us that is the first derivative. All right, sir, let's run it. The denominator, see here, sir? Bam, the denominator times the differentiation of the numerator. The differentiation of the numerator is a constant. The differentiation of a constant is equal to 0. So times 0. Then minus the numerator, minus 1, times the differentiation of the denominator. Differentiating the denominator, I'm going to get 1. Bam. All over the denominator squares. Got you, sir. Then now, remember, just like we did in the product question, multiplication comes first. So I have to do this side first, leave out the middle sign after. So 0 times all of that is 0. Then I'm going to have -1 times 1 is -1. See it over here, so? -1 over x plus 1 all squares. Sir, please expand the denominator. We never do. Leave it as it is. Leave the x plus 1 all squared as it is. So when you're doing the quotient rule, just be concerned about working with the numerator. Simplify the numerator. Simplify the numerator and just leave it like that. So this is the first part. This is the first differential. And if you look at the formula, since I have it here, let me just do it one shot. If you look at the formula says I'm going to find f of 0, meaning the original function, and I substitute 0 in there. Then I'm going to add it to substituting 0 into the first differential times it by x. Then the second one, I'm going to substitute 0 into the second differential, divide it by 2 factorial, times it by x squared, so forth and so on. So look at what Sir did. I found the first derivative, and then what Sir did was also find f of 0. F of 0. And f dash of 0, I'm sorry, f dash of 0. So f dash of 0 is putting in 0 into all of this. That's what it comes out to be. 0 plus 1 is 0. I mean 1. And 1 squared is 1. So I have -1 over 1, which is -1. And that's why I get a -1 right here. So that f dash of 0 works out to be -1.
Do it again.
All right.
Do it again.
So you understand that part, right?
Yeah, man.
Yes, sir.
Hold it. So all I'm doing here, anywhere in f dash of x I see 0, I'm going to find f dash of 0. I'm substituting 0. So the numerator stands alone because there is no x in there. The denominator has an x. So I'm going to say 0 plus 1 is 1. And 1 squared is 1. So -1 divided by 1 is -1. So I'm going to have that -1 right there. I'm going to put that in blue because I'm coming back to it. I have -1 right there. I have -1 right there. All right. Now, remember also said to you that you have to find f of 0. So since I'm given my f of x, I also need to substitute 0 in here. So the numerator stands alone again. 0 plus 1 is 1. So 1 over 1 is this one. So I've evaluated my f of 0 and I've evaluated my f dash of 0. Now remember, the question says for us to do x up to and included x to the 5th. Now x to the 5th You see, like x to the third, so we have to do the third differential. X to the second, so we have to use the second differential. So x to the fifth says that we have to do the fifth differential. All right? So watch what will happen now. I need to find f double dash of x. So in order to find f double dash of x, I have to use this one. In order to find f double dash of x, I need to differentiate my f dash of x another time. So we now have to differentiate the first differential in order to obtain the second derivative. Just remember that. In order for us to get the second differential, we have to use the first differential. All right, so I'm differentiating this one to give me this. So let's go. The denominator, x plus 1 all squares, see to yourself, x plus 1 all squares, times the differential of the numerator. The differentiation of the numerator, -1, is 0. That's why I have 0 here, so. That's why I have a 0 right here, so. All right, so it's the denominator, x plus 1 all squares, so give me this x plus 1 all squares, times the differentiation of the numerator. The differentiation of -1 is 0. Then minus the numerator. Oh dearest, I made a mistake. Minus the numerator is supposed to be minus 1. Oh dear, I made a mistake. Anyway, shows that I'm human. So I need to check to see what my answer comes out to be. Oh, my answer comes out to be the correct thing. All right, so it's minus the numerator, minus here, the numerator, and the numerator is -1. You can see that?
Yes, sir.
Minus the
Yes,
numerator
sir.
times the differentiation of the denominator.
Yes, sir.
No, the denominator. This is where the power rule comes in play. G's and P's, sir. So look at that, sir. One quotient rule contain the power rule also. Yeah, man. What the power rule says, sir, I'm going to take this 2 and carry it in front of this. So I'm going to have 2 times x plus 1. And then I have to times the differential of the inside, which is 1. See here? 2 times x plus 1 times the differential of x plus 1, which is just 1. So the power rule says that to take this oh, so far up here. Jesus. All right. See the power rule here? We have something like this. This is what the power rule says. Y is equals to 2x plus 5 to the second power. What we're doing here is to say this 2 multiply in front of this to give me this 2. We write back this, reduce this by 1, so that means we get to the first power. But then though we have to go and differentiate what is inside here. And the differentiation of what is inside here says it's going to be 2. So let's go again. So this 2 is going to multiply in front of this. So this is going to give me this 2 right here. And remember, I have to reduce this by 1. So that's why I get the 1 right here. Write back the function and put the 1 right here. Because I'm reducing it by 1. Then I know I have to differentiate what is on the inside. The differentiation of 2x plus 5. Remember, the plus 5 is a constant, so it goes to 0. So I'm just going to differentiate the 2x. So when I differentiate 2x, I'm going to get 2, which is this 2. This 2 now times this 2 gives me this 4. And of course, I'm just going to write back my 2x plus 5. I don't have to write the 1 because I know that it's a 1 there. And then if I want, I can say 4 times 2x is going to be 8x, and 4 times 5 is 20. So that's what the power rule says. I don't have to expand. I don't have to expand the 2x plus 5 times 2x plus 5 because they can give you a question. They can give you a question where this is they can give you a question where that is 6x minus 1 to the 5th power. Who can have time to sit down and multiply 6x times 1 times 6x times 1 times 6x times 1 times 6x times 1 times 6x times 1? Not me. So we have to use a power rule. So the power rule says 5 times 6x minus 1. So it's going to be 5 times, it's going to be 5 times 6x minus 1 raised to the 4th power. Can you see that? Because I'm reducing it by 1. Times the differential of the inside here, which is 6. All right? And then 6 times, no, yeah, which is 6. And then 6 times 5 is 30. I'm actually typing, so you don't see it. 6 is 18, so that's 180. Minus 30. So this is going to be 5 times 5 goes in front of here, which is this 5, times 6x minus 1, which is this. And I'm reducing this 5 by 1, so I'm going to get it back to be 4. And then I'm differentiating what is on the inside here. The differential of negative 1 is 0 because of constant. And the differential of 6x is going to be equal to 6. And then this 6 times this 5 gives me 30. And then I'm going to have my 6x plus 1 to the 4th. I left off the 4th power, forgive me. To the 1 to the 4th. And incidentally, that would be my answer. All right, and then that would be my answer. So I'm going to have 6 times 5 is 30, but I can't use this 30 to multiply inside here. Why, sir? Because the power is greater than 1. The power here is going to be 4. So I can't do any multiplication of this 30 inside of here because the power is greater than 1. So again.
So once it's greater than 1, you leave it, sir. You don't trouble it.
You don't trouble it, you leave it. All right. So so again, using the power rule says 6x minus y is equal to 6x minus 1 to the 5th power. You know, some students will say to me, sir, I could just go ahead and just multiply out 2x plus 5 by 2x plus 5, sir, since it's a squared. Yeah, I agree with you. I would agree too. But there are times when the power gets large, and the power can even be larger than this too. So I would say to students, learn the power rule, because they don't know what function they will give you there, and it will make life a little bit more complicated. So 5 multiplied by everything in front of the brackets, which is this 5 here, 6x minus 1 raised to the 4th power. 6x minus 1 raised to the 4th power. So here's 6x minus 1 raised to the 4th power. But I must now differentiate what is on the inside of the parentheses. And the differential of inside here is going to be 6, which is this 6. The differentiation is finished right here, but we need to fix it up. So this is going to become 6 times 5 is 30, and I'm writing back my 6x minus 1 to the 4th. Sir, but I don't do anything else because this is raised to the 4th. I cannot do anything else. All right? So with that said, I am going to do now this one here. So it's going to be times the differential of so it's the denominator. Let me just go over that again. The denominator, which is x plus 1 all squared, see here, times the differentiation of the numerator. The differential of the numerator, which is a -1, is 0. Minus the numerator, so I have to put minus, and then write back my numerator. Now, because the numerator is minus, like sir had it before, we're just going to drop one of the minus signs. It's very important because it's going to come over here for the answer. So I have to do that. Minus the numerator times the differentiation of the denominator. So in differentiating the denominator is a power rule. The power rule says x plus 1 squares is going to be this 2 in front of that. So it's going to be 2 times x plus 1, reduce the power by 1, and then times it by the differential of the inside. See here, that times the differential of the power inside. Now watch me. This 0 multiplied by everything here so goes to 0. All of this goes to 0.
Sir, hold on.
Mm-hmm.
Go one step back than where you were a while ago. You just go one step back. One step. That's the only thing I got mixed up with a while ago.
What step you want me to go back?
I want to go back to
the differential of the power rule here?
First derivative, yeah.
Power rule, all right. Hold on. All right, so recall the power rule. So recall the power rule. And I'm going to call this y equals. So recall the power rule, and I'm doing that. So copy, bam, bam. Okay, so recall the power rule, and I'm differentiating this function here. So what is going to happen now? My dy by dx is going to be equals to bam, bam times 1. Where do I find that? So my power rule says it's going to be 2. This 2 is multiplied. All right. Let me do something for you. Let me do something for you, Papa.
Down the power.
I'm doing something for you.
By negative by 1. Then you factor, you differentiate the inside, which gives you 1. The constant is close to 0.
All right, look at this here now. So this 2 is being carried forward to multiply here. See here? That little 2 here come down to come the big 2 right here. So, and then I'm subtracting 1 from the power. 2 minus 1 is 1 to get that. And then I'm finding the derivative of the inside here, so which is this 1.
Sorry, put the minus 1 up at the top.
Put the minus 1 where?
Right, so you just go. No, go back up, go back up. No, up. No.
No. I know what to do. That 2 minus 1 right there. And then now I'm gonna put this one. All right, so that's 1x. 1x, I'm going to differentiate 1x, I can get 1. So this 1 is from the differential of the inside right here. So, and then that no, copy, bam, 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 is when it gives me, I'm just going to do it now so that you can see what is happening. Bam, bam, times 1, bam, no, right, copy, bam, 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 this goes like that, so I have that. You know what? I don't need to get a power right here, because I'm that. Delete, bam, bam. All right, so look at what is happening here now.
Sir.
All right, so we have the last 10 minutes. Let us see if we can go through this now. So this is what, as a recall, I don't have a problem doing the recall. So recall the power rule. So this is what I did. Y is equal to all of this. Let me just go back through quickly. Because when I send this, you can finish it off for yourself. So this is going to be 2 here. Is this 2 times x plus 1. And then we have
1 from the power.
2 minus 1, good, times the differential of the inside, which is going to be this 1 here. And then no, 2 minus 1 is this is 1. And that 2 is this 2, and this 2 is, and that 1 is this 1. And then when I multiply this 1 by this 2, I'm going to get 2. And then I don't normally write the 1 up here, and then that is going to be my answer. Let me just put that in red to show that's my answer. And then I'm going to have that as my answer, and then that is going to be that. So that's how I get the 2 times x plus 1.
Okay.
And that's why I get it. And that's why I get it. So all of that is all of this that I have in the last part of here.
Yeah.
All right. Okay. Now, all I'm going to be doing here now is just to simplify. And when I simplify, all of this goes to 0. And then now this is going to be 1 times 2 times -1 is -2 times a -2 is going to be +2. And that's why I get my +2 up here. And then
that is where I lost a while ago. The extra negative.
Right.
The negative times a negative. All right, sir. Cool.
Good. And then notice, please note. Please note that I'm canceling out this x plus 1 because it corresponds to the same x plus 1 in the denominator. It corresponds to the same x plus 1 in the denominator. You notice the denominator power was 4. I'm canceling it out not to get 3. So that's how come I get the x plus 1 to the third. Can you see that?
Yes, sir.
Magic. Right? Magic. All right. So this is what is happening. So remember now. So it goes back to. Yeah, I'll come in to you. Just hold. Don't lose the question. Don't lose the question. Let me just say this. It goes back to this question I was doing right here when I was saying to you that you always factor out because there are times something in the numerator that can be cancelled in the denominator. In this case, when you factor it out, there's nothing that could be cancelled, but we leave it the same nonetheless. Come fast forward now. Fast forward now to this question here that we're doing. Fast forward to this question here that we're doing now. We recognize that here, so because all of these go to 0, so we're going to have 2x plus 1 over x plus 1 to the 4th. But the x plus 1 in the numerator here can be cancelled with one of the x plus 1 in the denominator here. Can be cancelled with one of them. So I'm going to cancel it out to make my life simple because if not, I would have had 2 times x plus 1 over x plus 1 to the 4th. So we normally cancel it down. If we don't cancel it down, it means that the differentiation that we can do for the third derivative is going to be a big and ugly something. And when you have a big and ugly something like that, when you differentiate it, your answer is going to be uglier. And you may make mistakes. So we always simplify. Shan, go ahead with the question.
So what happened to the other x plus 1?
Yes.
Yes.
It's times by 0. What happened when it's times by 0?
Yeah, but because it cancels this one here.
No,
you're saying that.
No, before you go further, which one of the x plus 1 are you talking about? This x plus 1 right here, so that I'm pointing at?
Yes, sir.
All right, work with me. This x plus 1 here, so that.
Yes, sir. That one I'm talking.
Teacher, it's being multiplied by 0, and 0 times anything is 0, so it cancels. It eliminates it. You see that?
Yes, sir. I see that, but
But what?
But the other one times 2 as well.
It doesn't, because there's this negative sign that separates them. Aha! So this is my separator. This negative sign right here, so, is my separator. Remember, the denominator times the differentiation of the numerator times the differentiation of the numerator. Multiplication comes before addition and subtraction. So this negative sign here, so, is my separator. So nothing over here can be cancelled with anything over here because there's a separator. Hold on. You cannot pass me. I am the barrier. You have to stay on one side of the road. So that's why this one cancels out, and I'm only left with this one here. But this one can be cancelled with one of these here, and I'm left with only 3 here.
Okay.
Good job. So then I get my differentiation here. Then I get my differentiation here, and then I'm going to find when f double dash of 0, I'm going to substitute 0 here. 0 plus 1 is 1, and 1 squared is 1 to the cube is 1, and 2 divided by 1 is going to be 2. I'm teaching for quite a while. Teaching for many years.
Sir, stop. When you say the last, 2 divided by what?
0 plus 1 all squares. And 0 plus 1 all squares is going to be 1 squares, which is 1. So 2 divided by 1 is 2. You see that?
Why no, alas.
Look.
Put your little mouse thing.
See here?
Yeah.
I am substituting 0 into this. So 0 plus 1
all right.
is 1. And 1 cube is 1. 2 divided by 1 is 2. So I'm saying to you that I have been a teacher for quite a number of years. The same energies that you started off the class with is no longer there. So I'm not even going any further with this question, because you're just looking at it, looking at the time to say, class soon done. And what I'm saying, just going through one eye and come through the other eye.
This money I can't tell people.
Sir, know the strips, you know.
Sir,
know the strips on the car.
Absolutely.
Reggie, me there in the hottest room in the house, brother. Me there from Monday to Friday, dog. I'm just alright.
And you are saying, don't worry about it. You can go and talk up in face.
No, me not say talk off your face, sir.
No, but in essence, that's what is happening, because you're not getting. So I am going to stop there. And what I'm going to do, I'm going to copy all the things that I would have used in class today. So I'm going to go to the document and copy out all of the things that I would have used in class today and send it off to you. No, you have to promise me. I'm not going to ask you immediately. No.
See those who are added to the group.
Say it again. You're not added to the group yet?
Sorry, I'm not seeing on pop up.
Yeah, man. Peter Gay. Peter Gay.
Peter Gay supposed to be on the Long Island ferry right now. You're supposed to be on the Long Island ferry by, you know.
All right, I will speak to her to remind her other students. All right, so do me so Peter.
Oh, hold on, Andre McIntosh.
No, McIntosh. No, McIntosh left. McIntosh left.
He mustn't have the group because he came on to the class, and I told her to share him in the group. So I wish your number.
Oh, Peter Gay is on, you know. Peter Gay not here.
She'd add some persons this morning.
Yes, calculus too. Yes, I'm in there. I found
yeah, man. Peter Gay cut. So that's seminar error.
I don't
You don't see it? And I think she's the only admin.
Should need to make more people the admin so we can chuck in.
Make sure the admin or something.
No, sir. You don't want that responsibility there. So somebody is so Shanice, I can get you sorted out. I'll speak to her. I don't know. Maybe she has internet problem.
Post a number in the chat so I can send it to her. Until
Post it.
She had admin. Peter get admin.
Yeah, I'd ask her to set up. Yeah, I'd ask her to set up for me before we met, so I could communicate with you guys.
Yeah, man. Right. I style alright, you know.
No, leave my admin alone. All right. So this is what I'm gonna do for you guys, because I know what is happening. I'm gonna take a little break myself. Then I'm gonna copy the stuff. I'm going to send off to you. I don't expect you to do anything now because you're tired. You need to get a little break. But you have to promise me. Yeah, me too. You have to promise me.
Supermarket and them hot sun, eh? No.
Don't go now. Wait till later.
No, none of that. Go supermarket from yesterday. Okay, I know.
You get paid yesterday.
We get paid Thursday. You know, government pay early.
Oh, bless the Lord. Oh yeah, we get paid from Thursday. Bless the Lord.
So sir, leave alone now, sir.
Huh? Remember, I'm a teacher, you know. Remember, I'm a teacher.
Sir, you're a teacher with a PhD.
Hello. Listen to me.
Doctor
Irrespective.
You're the head of your department. You are the go-to person for the CCCJ.
You notice
right?
For me,
what
I don't even look at the title
AKA 5-star general.
No, but guess what? Put it this way.
7-star general.
Put it this way. Do you know that some of the lecturers at the University of the West Indies and some of the lecturers at Exeter Community College are paid at the same rate? Real talk. Real talk. Right? And that's why when people say to me, wouldn't you go to the University of the West Indies to teach? Oh, why? I love Exeter, so that's why I'm at Exeter for so long. Right? Mark, you will have our shortcomings, but it's a great institution. We not ask nobody that. I tell you. Straight up. The point I make it is
sir, the way them hype up the other people when we interact with them, brother, remember me tell you, rhyming.
No, but I'm saying to you, Papa, it's just fluke. You know, a man can say, oh, I live up Jackshill. Yeah. Buy me a beer. wow, until it's in dry, you know. You can't buy my beer. But if you look a man, you know, you go to a domestic helper and you say to the domestic helper, they get $100 now. Listen to me, my shop man partner money, you know, because them people they know how to save out of nothing. So not because you drive an X6, it means say you ever go to a gas station and see that X6 driver put in $1,000 gas in a car?
Yes.
And the gas take a laugh off of them and say, oh, there was one I saw on TikTok, the man a drive one Mark X and I put in $500 gas in the car. Yeah, and the gas attendant them a laugh off of the man, you know. The man a drive a Mark X, but guess what? You may drive a Toyota Corolla and can put in $7,000 gas. So the point I'm making is, don't watch a man because a man lives on the pinnacle of a hill. You who live in a Portmore in one of them quads far better off than the man because you don't have NHT knocking on your door to say you owe the mortgage.
He have more disposable income.
And sometimes he's living above his means, but because he wants to be socially accepted. No, me I tell you, students.
That's why I can't move come out town.
Get me to tell you about living humble. You know, one quick thing in half a second. I was a banker before, and I remember when I went into the banking system to work, you have some pretty girls. You see, like Ocean is pretty. You have some pretty girls that work, and every country is pretty. Pretty girls are working at the bank, you know. And I tell you, we sit down and I said, no, I didn't face them. Come to come work. You're not able to focus. And we're going at the lunchroom, and I always look forward to lunchtime because the whole of the pretty girl them come sitting inside this. And I take my time and I eat, and I watch the pretty girl them. And one day, you know, a set of pretty girls said something about me, and it really crushed me. Them say, every day him come and a patty and juice him and eat. You know, when me start work out, me couldn't find our box lunch money. Me have to hold one patty, no. Them the days they know. You can use $100 and buy one patty and one drinks and get back change.
Yeah.
You understand? And me go buy my patty and me drink, and me sit down and eat my lunch, you know. And one of the pretty girls them say, every day I'm sitting and eat patty. Me couldn't do it, you know. But that client, me couldn't do it. Matter of fact, I can't even eat patties. I'm sit down and listen to it, you know. And I won't tell you what I said in my mind about them girls. And trust me, it whatever attraction or admiration I had for those girls, it went right through the window. Yeah, man.
Sir, I'm not that girl.
No, you're not that girl. No, you're not that girl. And I'm saying to myself, you know, just imagine all the man about the man pocket. And I sat down there and I said nothing. And I just kept to myself. And I remember when the first month end came and we couldn't wait until the 25th coming up because guess what? You never get paid. And the first paycheck we never get from when we just start working is to buy one box lunch. Right? Chinese food, you know, because we just couldn't afford it. Sure. We left university and just couldn't afford it. And when I went downstairs, you know who I met? A lady who was downstairs and said to me, excuse me, sir, you're going back upstairs? I said to her, I said, yes. Tell Shanice and tell Kimishian and tell Candice, say, me downstairs I wait upon my money. And I said to the lady, oh, you are the one who cooked the food? And she said, yes, tell them that I'm down here and I don't have much time. And trust me, I had a big smile on my face and I went into the lunchroom and I saw them. I said, excuse me, I'm sorry. But the lady that you purchased lunch from your day is downstairs waiting for her pay. And they all looked at me and they couldn't answer. And I went back downstairs and I said, I delivered your message. Let alone them go downstairs and say, nobody never get any message. I went back to the
God, no, you did that.
Purposefully. I said, I delivered the message. You see, long after, me go downstairs and see the lady. I said, I don't come to you yet. She said, no. You see, I go back in the lunchroom. Them girls are gone. Gone back to them station. Gone back to them station and I work. I hide her from the lady. What's the point, Mr. Shand? The point is, some people live above their means and look down on others when nobody there knock on my door and tell me, say, me for coming up, to come to that. Because guess what? When I got my pay that month and I never had to pay nobody, no money to no bus fare.
Well, like my one.
Listen to me. Yeah. You see, when you see a man driving X6 and him X5 and him Mark X and him this car,
be a stress.
You don't know what the person going through. Live in your lane.
never take a loan for anything other than a house. Everything that I
No, you can't take a loan for education too, you know. You can't take a loan for education.
I did not take a loan for that.
Right. But that is it. So I'm saying to you, my students, learn this from your teacher today. When you see a man elevating at the workplace, be happy for him. Because you don't know what that man is going through. And God forbid, sometimes you may see the man and you say, "Want to the car?" Or you went into the garage. Lie. The owners for the car come back for it. So I'm saying to you, live in your lane here. If you can afford a bicycle, ride a bicycle, go to work. Don't live above your means. And if you can't afford to buy a car to go to work, don't buy the car. Don't put yourself into additional stress to make you feel socially accepted. You see this youth? Them peer pressure that can't reach me. Can't reach me. So don't look at a man and say because a man is this, a man at work. Chances are you are working more than the man. You're more so you can talk about you go to supermarket. Some of the man them only on top of the week can't even go to supermarket. Day by day, them buy the food.
Sir,
real talk.
Sir, my supermarket is a little man named Mr. Chen.
I don't care.
Well, I know because I'm fixing camera system. He give me wholesale price like I have a shop. That's my supermarket.
You see the point I'm making? So I'm saying to you, papas, if you can only eat a tin of sardine, if you don't come and say, boy, Shandy knows how tin of sardine you eat, I don't know. If you
but sardine are luxury, you know much one.
No, which is what I'm saying. So a man up there so can't do it. A man up there so forgot driving exits and go to his friend and place a party.
Nice around to them, sorry.
Sardine nice.
But anyhow, guys, be blessed.
Squeeze one line on that and
nice, nasty. But anyhow, be blessed. Have a good one. Remember, stay within your means, and remember, study. I don't want to see anything less than 50% for the final.
I don't study maths. I practice it. So
you better start studying. You better start studying. Have a wonderful day,
sir.
Yeah.
And don't forget we one another time again because remember me tell you say if on a Saturday evening or Sunday, I get money, me not have that time because
yeah man. I will do that, man. Just got to tell you so 1-2 break and then do this up for you. No problem. No worry about that, man.
And don't drink no Campari.
Can't afford it. I mean, I live in my means. But I have to go wait until Romaro died for me.
No, that's why you have to talk to Macintosh. Macintosh work there.
Oh,
who you talking about?
Noted with Sam. Later, guys. Take care. Cool.